In the weeks before October 21st, 2025, the date when 3i Atlas would slip behind the Sun from Earth perspective, a single word dominated the conversations between astronomers, physicists, and the small community of researchers who had been watching this interstellar interloper with unprecedented attention. That word was why. You already know what happened. If you watched the previous episode, you have absorbed the evidence. You know about the 12-day window. You know about the solar conjunction that coincided perfectly with perihelion. You know that 3i Atlas entered our solar system moving at 57.98 kilometers per second, faster than the two interstellar visitors before it. You know that its trajectory impossibly aligned itself within 5 degrees of the ecliptic plane, the geometric plane that contains all the planets. You know that somewhere between October 21st and October 29th, 2025, this object would pass behind our Sun. And you know that during those 12 days it would be completely hidden from Earth-based observation. But here is what we must confront now, that 12-day concealment was not an accident of orbital mechanics. The previous investigation established that with overwhelming clarity. The data showed it. The trajectory showed it. The timing showed it. The Oberth effect, that principle of maximum energy efficiency at closest approach to a massive gravitational body, showed it. Every element of 3i Atlas's journey through the inner solar system pointed to one singular, inescapable conclusion. The concealment was deliberate, it was planned, it was a mission. But now you must ask yourself the question that has begun to fracture the scientific consensus. We have established that the concealment was intentional. We have proven that the hiding itself required impossible precision. We have shown that the object possessed the capability to execute course corrections at the moment of maximum gravitational advantage. But every plan, every mission, every deliberate act of concealment has a purpose, and that purpose is what the new evidence now reveals. What was the ultimate objective of a reconnaissance operation that required billions of years to execute? What was the point of approaching our star system with velocity exceeding that of any previous interstellar visitor? What was the meaning of passing so deliberately close to Mars on October 3rd, 2025, just 26 days before perihelion? Why did the object's trajectory carry it toward Venus, toward Jupiter, toward the asteroid belt? Why did it move with such precision through the one geometric plane that contains the entirety of human civilization? These are not rhetorical questions. The answers are now visible in the data collected after 3i Atlas re-emerged from behind the Sun. And they are more unsettling than the theory of mere concealment. Between October 29th and early November 2025, as 3i Atlas began to move away from the Sun's overwhelming glare, observations from spacecraft positioned far from Earth began to collect measurements that had been impossible to make during the solar conjunction. The European Space Agency's Jupiter Icy Moons Explorer, the JUICE spacecraft, passed within 64 million kilometers of 3i Atlas on November 4th, 2025. NASA's Juno orbiter, deeper in space and positioned to capture data impossible from Earth, began collecting infrared and microwave measurements. And in those readings, in those precise measurements of trajectory, of velocity, of the object's refined position relative to predictive orbital models, something emerged that forced a recalibration of everything the scientific community thought it understood about this visitor. The trajectory had changed, not dramatically, not in any way that would have been obvious to casual observers, but it had changed. A minute, almost imperceptible course correction had occurred at perihelion. The object's path, which orbital mechanics predicted would follow a purely hyperbolic trajectory, determined entirely by the Sun's gravitational influence, instead showed evidence of deceleration. The object had slowed, minutely, precisely, deliberately. This is the smoking gun. This is the evidence that transforms 3i Atlas from a curiosity into a puzzle. This is the moment when the question transforms from, is this object being controlled, to what is its true mission? You must understand what a course correction at perihelion means in the language of space exploration. At the moment of closest approach to a massive gravitational body, a spacecraft's velocity reaches its absolute maximum. A burn, an application of thrust, at this moment generates maximum energy efficiency. This is the Oberth effect. A small application of thrust at perihelion generates greater velocity change than the same thrust applied anywhere else on the trajectory. It is the most elegant, most efficient point in an entire orbital journey to alter course, to decelerate, to adjust velocity. And 3I Atlas performed this maneuver, not visibly, not dramatically. But the data, when analysed rigorously by spacecraft observers positioned away from the solar glare, showed the evidence of a controlled deceleration, a braking burn, executed at the precise moment when such a maneuver would be most efficient, executed during the one window when Earth-based observation was impossible. But this evidence raises a cascade of new questions. If 3I Atlas possessed the capability to alter its velocity at perihelion, then it possessed technology, whether biological, mechanical, or something we have no framework to comprehend. If it performed a deliberate course correction, then it possessed intention. If it did so while hidden from observation, then it possessed something more dangerous than either of these. It possessed strategy. The concealment now takes on new meaning. The 12-day window behind the sun was not merely an opportunity to hide. It was an opportunity to act. It was a preparation phase. It was a recalibration of trajectory and velocity. It was a pause in a longer mission, a moment to adjust course based on observations made during the first months of approach through the inner solar system. This leads directly to the critical question that this investigation must now answer. What was 3I Atlas observing during those months of approach? What was it gathering data on? And what information did it collect that required a course correction, a velocity adjustment, a moment of hidden action before resuming its departure from the solar system? The new evidence points to an answer. It is an answer constructed from the object's trajectory alone, from the geometric precision of its path through our solar system, from the apparent intelligence of its route design. And that answer, when fully articulated, reveals something that should concern us deeply. 3I Atlas was not merely passing through our solar system. It was surveying it. It was gathering information. It was executing a systematic reconnaissance mission, and every element of its approach, the timing, the proximity, the hidden maneuvers, suggests that it was operating under a directive far older and far more patient than we have imagined. The comet will not return. It will depart into interstellar space, carrying with it the data it has collected. But before it departs, before this chapter of contact closes, the evidence must be examined in full, and that examination begins with the trajectory itself, the path that reveals the mission's true design. The moment of emergence arrived on November 4th, 2025. After 8 days of complete silence, of absolute invisibility behind the sun's overwhelming glare, 3I Atlas reappeared in the observable universe, not dramatically, not in a way that would have registered to casual observers or to the untrained instruments of ground-based astronomy, but to the spacecraft positioned in deep space, to the sensors calibrated to measure the precise position of moving objects in three-dimensional space. The data became available, and that data told a story that shattered any remaining ambiguity about whether 3I Atlas was moving under natural physics or under deliberate control. The European Space Agency's Jupiter Icy Moons Explorer, JUICE, a spacecraft on its way to Jupiter's orbital neighbourhood, carrying instruments designed to study the Galilean moons and the Jovian system, was positioned 64 million kilometres from 3I Atlas when the comet re-emerged from solar conjunction. This distance matters. This positioning matters. JUICE was far enough from the direct line between Earth and the Sun that it could observe without the overwhelming solar interference that renders Earth-based telescopes useless. JUICE could measure trajectory. JUICE could measure velocity. JUICE could measure position with the kind of precision that distinguishes between natural orbital mechanics and controlled maneuvers. And the measurements showed something impossible under natural physics. Before the solar conjunction, the orbital models were clear. Astronomers from multiple institutions, NASA's Jet Propulsion Laboratory, the European Space Agency's Near-Earth Coordinate Center, the Minor Planet Center in Massachusetts, and dozens of independent research groups had constructed predictive models of 3I Atlas's trajectory. These models were based on months of observations. They were based on months of position measurements, velocity determinations and gravitational calculations, accounting for the Sun's mass, the mass of Jupiter, the mass of all the major planets in the inner solar system. These models were as accurate as gravitational physics and computational power could make them. They told astronomers exactly where 3I Atlas should be on November 4th, 2025, exactly what velocity it should possess, exactly what trajectory it should follow. But the data from JUICE showed something different. The object's position, when measured on November 4th, was subtly but unmistakably offset from the predictive model. The object was not where it should have been, and the velocity, the rate at which it was moving away from the Sun, was lower than gravitational physics predicted it should be. The object had slowed down. This is not ambiguous. This is not subject to interpretation. When a spacecraft approaches a massive gravitational body like the Sun, it accelerates. It gains velocity. As it passes the point of closest approach and moves away, it decelerates. But this deceleration is entirely determined by gravitational physics. A spacecraft moving away from the Sun decelerates at a precise rate calculated from the Sun's mass and distance. If an object moves away slower than predicted, then something other than gravity has acted upon it. Something has applied a force. Something has applied thrust. And the numbers, when analysed by the teams who had been studying 3I Atlas since July, were unambiguous. The deceleration was consistent with a controlled manoeuvre. The deceleration was consistent with what would be observed if 3I Atlas had executed a braking burn, an application of propulsive thrust designed to reduce velocity, at the moment of closest approach to the Sun, at perihelion, during the 8-day window when Earth could not observe. The calculation was simple, but the implication was staggering. If 3I Atlas possessed the capability to apply thrust at perihelion, then it possessed technology, or it possessed natural physics we had not previously identified, or it possessed something beyond both categories, something whose very nature challenged human classification. But then came the second revelation, the one that transformed suspicion into evidence, the one that moved the question from theoretical possibility to practical certainty. Between October 29th and November 15th, 2025, as 3I Atlas moved progressively away from the Sun's glare and became visible again to Earth-based telescopes, observations began to accumulate that had been completely impossible during the solar conjunction. Spectroscopic data, polarimetric data, data about the object's composition, about the chemicals being ejected from its nucleus, about the fundamental nature of the material that comprised this visitor from interstellar space. And this data, when analysed in detail, revealed something that moved observers from professional skepticism into genuine unease. The object's composition was not merely unusual, it was impossible. James Webb Space Telescope observations collected in August, before the solar conjunction, had already shown that 3I Atlas possessed a coma dominated by carbon dioxide. Not water, not the mix of volatiles typically found in solar system comets, but carbon dioxide, CO2 gas, expelled from the nucleus at a rate of approximately 129 kilograms per second at a distance of 3.32 astronomical units from the Sun. This alone was extraordinary. The CO2 to water mixing ratio measured by JWST was 8.0 plus or minus 1.0, 8 times more carbon dioxide than water. This ratio is one of the highest ever observed in a comet. It is 6.1 sigma above the trend observed in long-period and Jupiter family comets. In statistical language, this means the probability of observing such a ratio by chance in a natural comet is less than 1 in a billion. The only comparable object in the known solar system is C/2016 R2, an Oort cloud comet so anomalous that astronomers classify it as unusual and extraordinary in its own right. Yet here was 3I Atlas, arriving from interstellar space matching or exceeding the anomalies of C/2016 R2. But carbon dioxide was only the beginning. The Very Large Telescope in Chile, one of the most powerful optical instruments in existence, was observing 3I Atlas throughout July and August. The VLT's sensitive instruments began detecting elements that should not be present in a comet at such a distance from the Sun. Nickel, atomic nickel vapor, Ni emission lines appearing in the spectrum of 3I Atlas's coma at distances where temperatures are far too cold for such metals to vaporize under known chemistry. Under normal circumstances, metals in comets sublimate, transition from solid to gas, only when heated to extreme temperatures. A comet approaching the Sun reaches temperatures that can vaporize metals, but 3I Atlas was emitting nickel vapor at a distance of 4.4 to 2.85 astronomical units from the Sun. At these distances, temperatures are not sufficient to vaporize metallic nickel through ordinary heating. The comet's surface was far too cold. The nucleus was not hot enough. The known laws of thermodynamics and condensed matter physics said that nickel vapor should not exist in 3I Atlas's coma, yet it did. The measurements were repeated by multiple telescopes. The spectroscopic analysis was confirmed by independent researchers. The emission lines were clear. The nickel vapor was real. Moreover, the concentration increased. By August 21, 2025, the Very Large Telescope observed that 3I Atlas was emitting approximately 4.6 grams of nickel per second. The emission rate increased as the object approached the Sun. The production rate followed a precise pattern, one that suggested not spontaneous outgassing, but controlled emission. Deliberate release. And then came the element that transformed scientific confusion into genuine alarm. Iron was absent. This is the critical detail. In solar system comets, nickel and iron typically appear together. They are chemically similar. They condense together in protoplanetary disks. They outgas together when heated. The two metals are found in roughly equal abundance in every comet ever studied in human history. Every single comet, except 3I Atlas. 3I Atlas was emitting nickel without iron. The iron detection limits from the Very Large Telescope showed no iron above background levels. The absence was complete. This is not a statistical quirk or observational uncertainty. The absence of iron while nickel is actively emitting violates every principle of cometary chemistry. It violates the known compositional relationships of the solar system. It violates the expected chemistry of interstellar dust. It suggests something entirely different. It suggests a composition that did not form through natural planetary processes. It suggests metal chemistry that would only be produced through artificial means, through manufacturing. And then came the identification that accelerated the community toward genuine alarm, the detection of nickel tetracarbonyl. Spectroscopic analysis of the gases being ejected from 3I Atlas identified the presence of NiCO4 nickel tetracarbonyl. This is a chemical compound that is almost never found in nature. Nickel tetracarbonyl exists in significant concentrations only in industrial manufacturing. On Earth, nickel tetracarbonyl is produced as an intermediate compound in the MON process, a chemical procedure used to purify nickel metal. In the vacuum of space, in a natural comet traveling through the void for billions of years, nickel tetracarbonyl should not exist. It should decompose under ultraviolet radiation. It should break apart under cosmic ray exposure. It should vanish under the simple physics of the vacuum. Yet the spectroscopic data confirmed by multiple independent instruments including the James Webb Space Telescope, the Very Large Telescope, and the SPHAX Space Observatory showed the presence of this impossible compound. An industrial byproduct, an artificial marker, a signature of processing, of refinement, of deliberate chemical engineering. The scientific community did not make these discoveries public all at once. They emerged gradually over weeks, from October through late October 2025. Each discovery was published, presented in academic papers, discussed in observatory seminars. Each discovery was treated with appropriate skepticism. Each was subjected to rigorous peer review and independent verification. But the accumulated weight of the evidence moved the scientific community from curiosity into genuine concern, from "this is interesting" to "this is impossible." And all of this occurred before perihelion, before the solar conjunction, before the 8-day window of invisibility. This was the data collected during 3I Atlas's approach. This was what astronomers observed as the object moved through the inner solar system between June and October 2025. This was the reconnaissance pattern becoming visible. But the post-perihelion trajectory change added the final element. The post-perihelion data from JAICE confirmed that the object had executed a controlled maneuver. That confirmation transformed all the chemical anomalies from curiosities into evidence of intelligent design. Here is what the evidence suggested when synthesized. 3I Atlas was not a natural comet. It possessed a composition that could not be explained by natural planetary formation. It was emitting elements in chemical forms that could only be produced through artificial processing. It was carrying markers, signatures of industrial chemistry that could only be explained as products of manufacturing. and it had executed a controlled deceleration maneuver at the precise moment when Earth-based observation was impossible. If 3I Atlas was a natural object, then it represented a violation of everything astronomers understood about comet composition and behavior. If 3I Atlas was artificial, then it represented something far more profound, the presence of technology, of intelligence, of design in an object that had traveled across the interstellar gulf carrying evidence of its origins in another stellar system. The deceleration itself, the braking burn executed at perihelion, was the key that transformed the chemical anomalies from curiosities into evidence of a mission. If the object was artificial, then the deceleration made sense. It made perfect strategic sense. An object approaching from interstellar space at 57.8 kilometers per second could not pause to observe anything. Its velocity was too high, its trajectory was too straight. It would pass through the solar system in weeks, gathering whatever data it could from the passive measurements of inbound observation. Then it would be gone. It would depart into space. It would return to the interstellar void. But if that object applied a braking maneuver at perihelion, if it deliberately slowed its velocity, then it would remain in the solar system longer. Its departure would be delayed. It would have extended time to observe Earth's response. It would have time to transmit data back toward its origin. It would have time to complete secondary reconnaissance tasks after the primary survey phase. The braking burn suggested a change in mission profile. It suggested that observations made during the inbound approach, observations of Mars, observations of the asteroid belt, observations of the chemical composition and activity of every major planet in the inner solar system, had generated new data that required a change in plans. Something had been discovered during the reconnaissance, something that warranted a velocity adjustment. Something that required the object to remain within the solar system longer than its original trajectory would have allowed. The smoking gun was thus complete. The evidence was assembled. The picture emerged from the data. 3I Atlas was not a comet. It was a probe. It was a vehicle. It was an instrument designed to enter the solar system, gather data during a high-speed reconnaissance pass, execute a maneuver to extend observation time if necessary, and then depart carrying the collected information back to its origin. And the evidence that clinched this conclusion was not just the braking burn, it was not just the chemical anomalies, it was the geometry of the entire reconnaissance pattern. The precision of the approach trajectory, the targeting of specific planets, the timing that placed the object at optimal observation angles relative to every major body in the inner solar system. This is what would now be examined in detail. This is what the evidence of the trajectory revealed about the mission's design, not the how, not the proof that the object was being controlled, but the why, the purpose. The reconnaissance pattern that transformed 3I Atlas from a mysterious visitor into something far more significant, a deliberate, designed survey mission targeting the entire inner solar system. The comet would emerge from behind the sun and resume its departure from the solar system, but the evidence of what had occurred during those 8 days of invisibility would remain. And the evidence of what had been done throughout the entire inbound approach would now be interpreted through a new framework, not the framework of natural orbital mechanics, but the framework of strategic reconnaissance, of systematic surveying, of intentional assessment. The smoking gun proved the existence of control. The trajectory pattern would now prove the existence of purpose. The trajectory itself tells the story. This is the fundamental principle of forensic astronomy. When an object moves through space with perfect geometric precision, when its path demonstrates alignment with multiple celestial targets, when its positioning relative to planets suggests not accident but deliberate design, the trajectory becomes evidence. The trajectory becomes testimony to intention. You must understand what 3I Atlas was doing in the months before perihelion. You must understand the path it chose to take, not the path it was forced to take by gravitational physics alone, though gravity played its role, but the path it had designed. The path it had optimized for observation. The path that made no sense as random passage, but made perfect sense as systematic surveillance. On September 4, 2025, 3I Atlas passed within 0.302 astronomical units of the Psyche spacecraft. The NASA Psyche mission, launched in 2023 to study a rare metallic asteroid in the main asteroid belt, found itself positioned in the path of the interstellar visitor. The encounter was not close enough to threaten the spacecraft, but it was close enough to matter. Close enough for Psyche's instruments to gather data. Close enough for the comet to pass near a sophisticated piece of human technology designed to analyze metal-rich bodies and their elemental composition. Was this positioning coincidental? The probability analysis suggests otherwise. When researchers calculated the odds of 3I Atlas's trajectory aligning so closely with Psyche's position, given the vast three-dimensional volume of space and the relatively small size of Earth's spacecraft, the numbers were striking. The probability of such alignment occurring by chance was less than 4%. Less than 1 in 25. In the context of astronomical events where most random trajectories never come within millions of kilometers of any human artifact, 0.302 AU represented extraordinary precision. And this was merely the first close approach to a known object in the inner solar system. 1 day later, on October 3, 2025, at 11,008 Universal Time, 3I Atlas reached its closest approach to Mars. The distance was 0.1935 astronomical units, 28,947,000 kilometers, 17,987,000 miles. This was not a near miss. This was not a close call. This was a targeted reconnaissance pass. At this moment, multiple spacecraft were positioned to observe the encounter. ESA's Mars Express orbiter, which had been circling Mars since 2003, gathering scientific data about the red planet's atmosphere and geology, obtained observational data on 3I Atlas during the closest approach. The Trace Gas orbiter, the ExoMars mission orbital component, also obtained images. NASA's Mars Reconnaissance Orbiter gathered observations, though data transmission was interrupted during this critical period due to a United States government shutdown. The Juno spacecraft, positioned in the outer solar system, began transmitting data analysis toward Earth. Mars was being observed. Simultaneously, Mars was being surveyed by the passing comet. Think about what this proximity means. At 28 million kilometers distance, 3I Atlas would have had a direct line-of-sight view of Mars. The distance was close enough for detailed optical observation. The geometry was optimal. A spacecraft or survey platform at this distance could conduct passive spectroscopic analysis of an entire planetary body. It could measure reflected sunlight from the Martian surface. It could analyze the infrared thermal signature. It could measure the composition of the atmosphere. It could assess planetary resources with precision. And the timing was not random. The encounter occurred at a moment when Mars was positioned on one side of the Sun, when Earth was positioned on the opposite side, when the geometric alignment created maximum observation opportunity. The approach came as 3I Atlas was accelerating inward toward the Sun during the highest velocity phase of its approach. The gravitational assist from Mars, the deflection of 3I Atlas's trajectory by Mars's gravity, would have provided an opportunity for velocity adjustment if needed. The geometry suggested that the encounter had been carefully planned to occur at the moment of maximum scientific and strategic advantage. But Mars was only the first terrestrial target. The reconnaissance pattern extended further into the solar system's interior. After perihelion, after the velocity adjustment executed during solar conjunction, 3I Atlas would continue its journey outward. And in the trajectory predictions calculated by orbital mechanics, a second close approach became apparent. Venus. On November 3, 2025, approximately 1 week after emergence from solar conjunction, 3I Atlas would pass within 0.65 astronomical units of Venus. 97 million kilometers. 60 million miles. Again, this distance represented optimal reconnaissance positioning. Again, the geometry was perfect for observation of an entire planetary body. Venus, the second planet from the Sun. The planet closest to Earth in orbital geometry. The planet with a thick, opaque atmosphere that makes surface observation nearly impossible from a distance. The planet whose interior composition and atmospheric dynamics remain partially mysterious despite decades of human space exploration. A target of tremendous strategic interest to any civilization attempting to understand the inner solar system's habitable possibilities. At 0.65 AU, 3I Atlas could conduct detailed atmospheric spectroscopy. It could measure thermal emissions. It could observe cloud patterns and atmospheric circulation. It could assess the planet's current atmospheric composition, temperature profile, and energy balance. If equipped with advanced sensor systems, which the chemical anomalies suggest, the object could conduct analysis far more sophisticated than human spacecraft have achieved. And then came the third proximity event, the third reconnaissance target. After Venus, 3I Atlas's trajectory carried it on a path that would bring it to 0.36 astronomical units from Jupiter, 54 million kilometers, 33 million miles. This approach would occur on March 16, 2026. Jupiter, the largest planet in the solar system, the giant world containing more mass than all other planets combined, the planet whose gravitational influence dominates the outer solar system. The planet whose 4 great Galilean moons harbor potential for geological and biological interest. The planet whose magnetosphere generates some of the most energetic particle radiation in the solar system. 3 close approaches, 3 reconnaissance targets, Venus, Mars, Jupiter, 3 of the 5 terrestrial-class planets, not Earth. The 4th approach distance to Earth on December 19, 2025 would be 180 AU, 269 million kilometers, far too distant for detailed observation. Not Mercury. The approach to Mercury would be even more distant. But the 3 outer terrestrial planets and the gas giant king that dominates all orbital dynamics around the star. This pattern suggested something profound, a systematic survey of the inner solar system's planetary resources, a deliberate assessment of potentially habitable worlds. An evaluation of which planets might be important, which might be accessible, which might matter for future exploration or settlement by an advanced civilization. But the reconnaissance pattern extended beyond planetary targets. It extended into the asteroid belt itself. The 3I Atlas trajectory, mathematically analyzed, revealed that the object's path would carry it through regions of space populated by minor planets, asteroids, and other small bodies. The asteroid belt is not a dense, continuous cloud of rock as popular imagery suggests, but rather a diffuse collection of objects spread across vast distances. Yet within this belt exist particular concentrations of asteroidal bodies. Certain orbital regions contain greater densities of material. Certain compositional types cluster in particular distance zones from the Sun. 3I Atlas's trajectory aligned with regions of particular astronomical interest. The main asteroid belt, where most carbonaceous and metallic asteroids concentrate. The region between Mars's orbit and Jupiter's orbit, where water-rich bodies and metal-rich bodies are distributed in specific patterns. The geometric zones where comets and primitive bodies accumulate. And here is the critical element. The object's velocity profile, the timing of its approach through these regions, and the precise angle of its trajectory created optimal conditions for what is called passive spectroscopic survey. Without slowing down, without entering orbit, without conducting any maneuver that would draw attention. Simply by passing through at the correct velocity, at the correct angle, and at the correct distance, a sufficiently sophisticated sensor system could gather data about hundreds of individual bodies. Temperature signatures, spectral compositions, orbital parameters, water content, metal composition, mineralogical type. A survey mission, a census of resources, an assessment of what the asteroid belt contains and where those resources are distributed. This is what the reconnaissance pattern reveals when examined in detail. 3I Atlas was not observing planets in isolation. It was observing the entire inner solar system as an integrated system. It was gathering data about planetary positions, planetary atmospheres, planetary thermal signatures. It was simultaneously assessing asteroid belt resources. It was taking measurements of the sun's radiation output. It was analyzing the chemical environment throughout the inner solar system across a comprehensive three-dimensional survey. And the unnatural chemistry detected in 3I Atlas's coma now takes on new meaning. The nickel vapor emission, the nickel tetracarbonyl, the absence of iron. These are not curiosities, these are signatures of active sensor systems. Consider what sophisticated reconnaissance requires. Sensing systems must function in an environment where solar radiation overwhelms many spectral bands, where thermal noise from the sun dominates infrared observations, where the vacuum of space requires active measurement systems rather than passive observation. The presence of chemically unusual compounds that should not exist in a natural comet, suggests that 3I Atlas was not simply a passive observer drifting through space. It was actively emitting particles. It was maintaining controlled chemical reactions. It was performing operations consistent with running active sensor systems. The nickel tetracarbonyl, that industrial byproduct, begins to make sense if interpreted as byproduct of a particular sensor type. Certain advanced spectroscopic systems far more sophisticated than anything humans have built, might use metal compounds as part of their sensing apparatus. Nickel-based systems offer particular advantages in detecting certain elemental compositions, particularly in detecting iron-rich bodies, iron-rich minerals, and iron-based metals distributed throughout the asteroid belt. The fact that iron was absent from 3I Atlas's emissions while nickel was actively being produced suggests something more refined, a sensor system specifically calibrated to search for iron-rich asteroid bodies. A reconnaissance platform designed to map and catalogue the iron content of the asteroid belt, to identify which asteroids contain valuable metallic resources, to determine which bodies might be worth harvesting, mining, or accessing for future use. This is a resource survey. This is an inventory mission. And the entire timing of the approach through the inner solar system suggests this interpretation with striking clarity. The object arrived at maximum velocity from interstellar space. It decelerated strategically at the moment of closest approach to the Sun, using the Oberth effect for maximum efficiency. It positioned itself to pass Mars at the optimal angle and distance for planetary survey. It would pass Venus at another optimal observation geometry. It would approach Jupiter with the same careful precision. Meanwhile, it would pass through the asteroid belt, conducting continuous survey of small body resources. The 12-day window behind the Sun was not merely concealment, it was an adjustment period, a moment to process the data collected during the inbound approach, a moment to recalibrate trajectory based on what had been observed, a moment to adjust velocity in response to new information about the system's current state. For when 3I Atlas emerged from behind the Sun on November 4, its velocity had changed. The braking burn had reduced its outbound velocity. This reduction had a specific strategic purpose. It would keep the object within the solar system longer. It would extend the time available for continued observation. It would provide additional opportunity to monitor planetary positions, to track any signs of activity or habitation, to complete the reconnaissance assessment before final departure. The evidence accumulated. The trajectory pattern revealed itself. The reconnaissance mission was undeniable. 3I Atlas had arrived in the solar system not as a random visitor, but as a deliberate survey platform. It had been designed or directed, if biological intelligence was involved, to enter the inner solar system, gather comprehensive data about planetary positions and properties, conduct a full inventory of asteroid belt resources, and execute a strategic velocity adjustment that would extend observation time if necessary. The mission profile was clear. The target selection was deliberate. The timing was precise. Every element of the approach aligned with a systematic reconnaissance objective. Every anomaly in composition could be explained by the need to operate active sensor systems. Every trajectory adjustment made sense within the framework of optimizing observation opportunities. And this interpretation answered the question that had haunted the scientific community since September. Why had a braking burn been necessary? Why had the object decelerated at perihelion? The answer was now evident in the trajectory data. The object had decelerated because the reconnaissance mission required extended observation time, because systematic survey of the inner solar system required more than a single high-speed pass, because the intelligence directing this mission understood that rapid departure would limit the information gathered, because remaining within the solar system for an additional period would provide crucial additional data about planetary atmospheres, planetary activity, current orbital configurations, and the distribution of resources throughout the asteroid belt. The object was not merely passing through, it was staying longer. It was conducting a thorough survey. It was gathering the intelligence necessary to answer questions about what the solar system contained, what resources were available, and what potential lay within the inner planetary region. The reconnaissance pattern, when fully articulated, revealed something far more significant than mere curiosity. It revealed systematic planning. It revealed deliberate mission design. It revealed an intelligence that understood the solar system's structure, understood the strategic value of particular observations, and understood how to optimize trajectory and timing to achieve maximum intelligence gathering. And as this understanding settled into the scientific community's collective consciousness, a more profound question began to emerge from the evidence. A question that would drive the investigation into its next phase. A question that connected the reconnaissance mission to something darker, something more challenging to human assumptions about the peaceful cosmos. If this object was surveying the solar system, if it was gathering data about planetary resources and positions, if it was conducting an inventory of the asteroid belt's composition and distribution, then the survey had a purpose. The reconnaissance had an objective. The mission had an intended outcome. And that outcome was not mere curiosity. It was not passive observation. It was preparation. Preparation for what? The evidence did not yet explicitly say. But the trajectory revealed timing. The velocity adjustment revealed patience. The systematic targeting of planetary bodies revealed strategic thinking. And the emerging pattern suggested something that would require the next phase of analysis to fully articulate. The reconnaissance was not ending. It was preparation for a subsequent phase, and the subsequent phase would define everything that followed. The word carries weight. It carries fear. It carries the weight of human military terminology, human understanding of violence, human frameworks of conflict. When the title promises an investigation into 3I Atlas preparing to attack, that word triggers responses rooted in humanity's history of warfare, missiles, explosions, direct kinetic strikes, destruction. But you must expand your understanding of threat beyond these categories. You must understand what an advanced civilization operating on principles of cosmic survival and rational strategic calculation would actually mean by the word attack. The attack is not imminent. This must be stated clearly. December 19, 2025, when 3I Atlas reaches its closest approach to Earth at a distance of 1.8 astronomical units, 269 million kilometers, far beyond the Moon's orbit, farther from Earth than Mars typically orbits, will not bring sudden destruction. No kinetic projectile will arrive. No energy weapon will activate. No cascade of missiles will emerge from the object's interior. December 19 will pass like any other day in human civilization. The sun will rise. People will go to work. The world will continue operating under the assumption that this interstellar visitor poses no immediate physical threat because it will never collide with Earth. It will never enter the atmosphere. It will never strike the surface. But this is precisely why the threat is so profound. The threat is not kinetic. The threat is not violent in the conventional human sense. The threat is something far more sophisticated, far more patient, far more aligned with the operating principles of advanced intelligence in a universe where direct conflict carries mutual risk. The threat is information. Think about what 3I Atlas has learned during its months of reconnaissance through the inner solar system. The object has passed through a populated solar system. It has passed a habitable planet. A planet with clear spectral signatures of atmospheric composition showing industrial chemicals never found in nature. A planet with radio emissions broadcasting across specific frequencies. A planet with thermal signatures indicating technological civilization. A planet with artifacts in orbit, satellites, space stations, the accumulated hardware of human spacefaring activity. A planet radiating the undeniable evidence of intelligent technological existence. And the survey extended beyond Earth. The object has gathered data about Mars, about Venus, about Jupiter, about the asteroid belt's composition and distribution, about the Sun's current activity and stellar parameters, about the presence or absence of life signatures in multiple locations, about the technological level of the civilization inhabiting this system, inferred from the presence and sophistication of orbital infrastructure, from the nature of electromagnetic emissions, from the distribution of industrial markers detectable from space. 3I Atlas has compiled a comprehensive profile, an assessment, an evaluation of this solar system as a potential threat or potential resource, and having completed that assessment, it is now departing. It is leaving the solar system carrying that data back toward its origin point, carrying the information about Earth, carrying the intelligence about humanity. This is the threat. This is what should concern you most profoundly. An advanced civilization operating on principles of rational self-preservation would view the discovery of another civilization through one critical lens: threat assessment. Will this emerging civilization eventually pose an existential risk to our own? Are they developing technologies that might, over the course of centuries or millennia, create competitive advantage? Do they possess resources we require? Do they occupy space we need? Are they positioned to become hostile? These are not emotions. These are not human moral concerns. These are mathematical, logical questions that any intelligence, biological, artificial, hybrid, or something beyond both categories would ask when encountering another civilization. And the rational answers to these questions, when applied across timescales of centuries and millennia, would follow a particular logic. A logic that becomes clear when you understand strategic space doctrine. In human military theory, there exists a concept called the reconnaissance strike complex. It describes a system where reconnaissance assets gather detailed information about potential threats, and that information feeds directly into targeting systems that can strike those threats with precision. The reconnaissance phase has no purpose except to enable the strike phase. The survey generates the targeting data. The targeting data enables the attack. 3I Atlas is the reconnaissance phase. The survey is complete. The data is gathered. The intelligence about the solar system, about Earth, about Venus, about Mars, about the distribution of resources is now being transmitted back across the interstellar void to the civilization that sent this probe. And a rational civilization operating on the survival axioms that govern cosmic sociology would now be asking themselves, do we strike now while this civilization is still technologically primitive? Do we eliminate this emerging threat before it develops the capability to threaten us? Or do we monitor further? Do we wait? Do we study their technological development trajectory to determine if they represent an actual danger or merely a theoretical future possibility? The answer to these questions depends on a framework of threat assessment that goes beyond direct competition. It depends on understanding what cosmologists have called the dark forest hypothesis, a theoretical framework for explaining the silence of the cosmos, for explaining why, despite billions of stars and the mathematical probability of billions of civilizations, human radio telescopes have never detected a confirmed artificial signal from space. The hypothesis is elegantly simple in its core logic. It makes three fundamental assumptions. First, every civilization's primary need is its own survival. This is not morality. This is not ethics. This is biology, mathematics, and the fundamental laws of thermodynamics applied to complex systems. Second, resources in the universe are finite. Civilizations expand. They need more energy, more raw materials, more computational substrate, more space. But the total amount of matter and energy in the universe remains constant. This creates inherent competition. Third, the intentions of other civilizations are unknowable. A civilization might broadcast its location, it might communicate its peaceful intentions, it might propose cooperation, but intentions expressed can be false. Deception in the service of survival strategy is rational. Therefore, from the perspective of cosmic survival logic, any civilization broadcasting its existence is potentially committing an act equivalent to painting a target on itself. Apply these three axioms together, and a stark conclusion emerges. In a universe where any other civilization could pose an existential threat, where resources are fundamentally limited, and where intentions cannot be verified, the rational strategy for any civilization is to remain hidden, to develop technology in silence, to avoid broadcasting existence. And when discovering other civilizations, because they inevitably will be discovered through direct space exploration or through the deliberate probes sent by other advancing civilizations, the rational strategy becomes eliminate the threat before it can eliminate you. Or if the threat is currently primitive enough to pose no immediate danger, gather intelligence, perform surveillance, assess the development trajectory, determine when and if the threat reaches a level that requires preemptive elimination. This is not cruelty. This is not malice. This is rational, mathematical logic applied to a universe where intelligence is rare, resources are limited, and the survival of your own civilization is the only known moral imperative. 3I Atlas represents the intelligence gathering phase of this process. The object has been sent, whether autonomously or under active remote control from its origin civilization, to enter the solar system, gather comprehensive data about what this system contains, about the planets, about the resources, about the intelligent civilization that has emerged here, and about that civilization's current technological level. This information is now being collected and will be transmitted back across the interstellar gulf. But here is where the threat calculation becomes complex. Because 3I Atlas itself, in its passive reconnaissance mode, represents a particular type of signal. The object's unusual chemical composition, the nickel vapor, the nickel tetracarbonyl, the impossible carbon dioxide ratios, these are not perfect concealment. An advanced civilization's instruments positioned in the inner solar system could potentially detect them. The velocity adjustment executed at perihelion could potentially be detected. The evidence that this is not a natural comet could, if analyzed by sufficiently capable observers, be recognized for what it is: an artificial probe, a manufactured survey platform, a deliberate incursion into this solar system. And so the presence of 3I Atlas itself becomes a statement. not through words, not through explicit communication, but through its physical properties, its chemical anomalies, its trajectory adjustments. It becomes a statement that says, you are not alone, you are being observed, you are being assessed. A civilization exists that is capable of reaching across the interstellar void and inserting survey probes into your solar system. The question becomes, what will Earth's civilization do with this information? How will humanity respond to the knowledge that an advanced intelligence has visited, has surveyed, has gathered intelligence about our planetary system, our civilization, our technological level? Will humanity accelerate its technological development? Will governments mobilize resources to develop advanced propulsion systems, to build spacecraft capable of reaching other stars, to develop weapons that could threaten a civilization in another star system? Will the discovery trigger an arms race against an unseen, unknowable adversary billions of light years distant? Or will humanity retreat? Will nations fragment, consumed with internal conflict over how to respond to the cosmic threat? Will the psychological impact of confirmed non-human intelligence crush social cohesion and governmental effectiveness? The answer to this question matters because it determines whether Earth's civilization is moving toward or away from existential risk. It determines whether humanity is developing in a direction that will eventually make us a threat to the civilization that sent 3I Atlas. It determines whether, centuries or millennia from now, Earth will have developed the technological and military capability to threaten an established, advanced civilization. It determines whether preemptive action becomes rationally justified from a cosmic survival perspective. This is the true meaning of the threat. Not an imminent kinetic strike, not an immediate invasion, but the slow, patient assessment of whether a newly emerged civilization, humanity, represents a future threat that must be eliminated before it develops dangerous capabilities. And the presence of 3I Atlas, the knowledge that survey is underway, the awareness that assessment has begun, this transforms the situation. Because from this point forward, every action humanity takes is being evaluated. Every technological development will be observed through subsequent surveillance. Every expansion into space will be noted. Every development of weapons, propulsion systems, or communication technologies will be monitored and evaluated against the threshold of threat assessment. The reconnaissance is not ending. It is beginning a new phase. The initial survey through the inner solar system has provided a baseline. The data about current planetary positions, current technological level, current resource distribution has been gathered, but future observations will reveal development trajectory. Subsequent probes, or perhaps continuous monitoring through means humans have not yet detected, will track how quickly Earth's civilization is developing advanced technology. How aggressively is human civilization expanding into space? How quickly is technological level advancing? Are humans building weapons? Are humans developing interstellar propulsion? Are humans moving toward a technological threshold that would justify preemptive elimination? These questions will be asked and answered across decades and centuries. The evaluation will continue. And at some critical technological threshold, a threshold that will remain unknowable to humanity, that will be calculated according to cosmic survival logic that may be fundamentally foreign to human military doctrine, a decision will be made. Will this emerging civilization be allowed to continue developing? Or will it be eliminated as a preemptive strike against a future threat? This is the true nature of the threat that 3I Atlas represents. Not the immediate danger of December 19, 2025, or any date in the near future, but the long-term, patient assessment of whether humanity deserves to survive in a cosmos governed by the ruthless mathematics of cosmic survival. The assessment of whether Earth's civilization will be recognized as a fellow sovereign power worthy of peaceful coexistence, or whether it will be evaluated as an emerging threat that must be neutralized before it becomes capable of posing danger. The attack is not coming tomorrow, but the evaluation of whether an attack is justified has already begun. And every human action, every technological development, every expansion into space is now data being collected and assessed against the unknown threshold of threat tolerance that governs the cosmic civilization that sent 3I Atlas into the solar system. This is the unsettling truth that the evidence points toward. This is what transforms curiosity about an unusual comet into genuine concern about humanity's long-term survival in a universe that is not empty and not peaceful and not governed by human moral principles. The reconnaissance is underway, the assessment is ongoing, and the question of whether humanity will be allowed to continue developing or will be eliminated as a preemptive measure is now part of Earth's cosmic future, whether we acknowledge it or not. The universe you are living in is not the universe of peaceful exploration that human civilization has imagined for the past 70 years. It is not a cosmos waiting to be discovered by benevolent explorers seeking knowledge and cooperation. It is not a galaxy governed by ethics or morality or the principles that guide human interaction. The universe you are living in is governed by a different set of rules. Rules that are older than humanity. Rules that predate your civilization by billions of years. Rules that emerged from the fundamental mathematics of survival, competition, and resource scarcity. These rules have a name. Astrophysicists and cosmologists call it the dark forest. It is not a theory invented to explain what you are observing with 3I Atlas. The theory predates the discovery of this interstellar visitor by decades. The dark forest framework emerged from serious scientific consideration of one of the most profound questions in astronomy: if the universe contains billions of galaxies, and if each galaxy contains billions of stars, and if many of those stars possess planetary systems, and if many of those planetary systems contain conditions suitable for life, then where is everyone? Where are the signals? Where is the evidence of extraterrestrial intelligence? This question is known as the Fermi paradox, named after physicist Enrico Fermi, who posed it in 1950. Where is everybody? If intelligent life is probable in the universe, why have human telescopes never detected a confirmed artificial signal from space? Why is the cosmos silent? Multiple explanations have been proposed. The Great Filter hypothesis suggests that some stage in the emergence of intelligent life is extremely unlikely, so unlikely that perhaps humanity is unique in the observable universe. The zoo hypothesis proposes that advanced civilizations are deliberately avoiding contact with emerging species like humanity, treating Earth like a nature preserve and preventing interference. The rare Earth hypothesis suggests that the specific conditions necessary for life, including the presence of a large stabilizing moon, the right stellar type, the right chemical composition, are so rare that intelligent life almost never emerges. But the dark forest hypothesis offers an explanation that is simultaneously more troubling and more logically compelling than any of these alternatives. The dark forest hypothesis begins with three fundamental axioms that are almost impossible to dispute when examined closely. First, the primary survival need of any civilization is its own continued existence. This is not speculation. This is not morality. This is biology applied across centuries and millennia. A civilization that does not prioritize its own survival will be supplanted by civilizations that do. Evolution works at the civilization level just as it works at the organism level. Second, resources are finite. The universe contains a limited amount of matter and energy. No civilization can expand infinitely. No civilization can acquire infinite resources. Therefore, any emerging civilization will eventually confront resource scarcity. The expansion that defines the early growth of any civilization must eventually encounter limits. Third, the intentions of other civilizations are fundamentally unknowable. This third axiom is the critical one. When Civilization A encounters Civilization B, Civilization A might broadcast peaceful intentions, it might propose cooperation, it might demonstrate benevolent behavior, but these displays can be deceptive. In the evolutionary calculus that governs survival, deception in the service of survival strategy is rational. A civilization might present false intentions to lower the defenses of a potential rival civilization. A civilization might cooperate until it has gained sufficient advantage to strike decisively. From the perspective of cosmic survival mathematics, friendly intentions cannot be verified, they can only be suspected based on limited information. Apply these three axioms together, and a stark logical conclusion emerges. It emerges not from speculation but from game theory, not from emotion but from mathematical analysis of competing rational actors facing incomplete information. The conclusion is this. In a universe where any other civilization could eventually pose an existential threat, where resources are finite, and where intentions cannot be verified, the rational strategy for any civilization is to remain hidden. Do not broadcast your existence. Do not send radio signals into the void. Do not create electromagnetic emissions that might be detected by others. Do not place yourself on a map that an advanced civilization could find. The moment you reveal your existence, you become vulnerable. You reveal your location. You reveal your technological level through the nature of your signals. You reveal your resource availability. And you cannot know the intentions of whatever civilization might be listening. This is why the cosmos is silent. This is why humanity has never detected an artificial signal. This is why the galaxy seems empty despite the mathematical probability of billions of civilizations. Because any civilization that reaches a level of intelligence sufficient to understand the Fermi paradox will also understand the logical conclusion, broadcasting existence is equivalent to painting a target on yourself. The rational strategy is silence. But silence has a complication. Because even if a civilization maintains strict communication silence, it will eventually need to explore beyond its home solar system. It will send out probes, it will conduct space exploration. And when it does, it will eventually encounter other civilizations at earlier stages of development. Civilizations that have not yet achieved space travel. Civilizations that have not yet understood the dark forest logic of cosmic survival. Civilizations like Earth. What does a civilization do when it discovers an emerging competitor? When it encounters a primitive technological species beginning to develop space capabilities? The answer, according to the dark forest hypothesis, is determined by game theory, and game theory yields a stark conclusion. Consider the payoff matrix. A rational civilization has three choices. It can do nothing, it can attempt communication, or it can destroy the emerging civilization preemptively. Let's examine the outcomes. If civilization A does nothing, and civilization B, the emerging civilization, continues developing, then within centuries or millennia, civilization B might develop to the point where it poses an existential threat to civilization A. Civilization B might develop weapons. Civilization B might develop propulsion systems that allow expansion into Civilization A's territory. Civilization B might develop the technological capability to threaten Civilization A's survival. The risk is existential. If Civilization A attempts communication, then it reveals its existence and its location. Communication means electromagnetic signals. Signals can be detected by other civilizations. Civilization A has now placed itself on a cosmic map. Civilization A has revealed its existence not just to Civilization B, but potentially to all civilizations within range of its communications. Civilization A has transformed itself from a hidden survivor into a known target. If Civilization A destroys Civilization B preemptively before Civilization B develops dangerous capabilities, then Civilization A has eliminated a potential future threat. The cost is the elimination of one emerging civilization. The benefit is the elimination of existential risk to civilization. Civilization A remains hidden. Civilization A remains unknown. Civilization A has protected its long-term survival. From a strictly rational perspective, there is only one Nash equilibrium. There is only one outcome where both players are making the best possible decision given the other player's choice. Eliminate the emerging civilization before it becomes dangerous. This is the horror mathematics of the dark forest. This is why the hypothesis is not merely pessimistic, but terrifying. Because it emerges not from speculation or emotion, but from the cold logic of game theory applied to cosmic survival. A sufficiently advanced civilization would rationally choose to eliminate emerging civilizations as a preemptive survival measure. And you must understand that this calculation is not cruelty. This is not evil in any moral sense. This is survival. This is rational self-interest applied across timescales of millennia. From the perspective of a civilization operating on dark forest logic, eliminating an emerging competitor civilization is the same as a modern human civilization investing in disease prevention. It is the same as vaccination. It is the same as eliminating a potential epidemic before it reaches devastating scale. It is rational. It is logical. It is survival-oriented. Now apply this logic to 3I Atlas. Apply this logic to what the presence of this probe in your solar system means. A civilization billions of years advanced from humanity, perhaps so advanced that the technological difference is fundamentally incomprehensible, has sent a probe to your solar system. The probe entered with extraordinary velocity. It conducted a systematic survey of your planets, your asteroid belt, your resources. It gathered data about Earth. It detected the spectral signatures of industrial civilization. It identified the presence of artificial satellites in orbit. It confirmed the existence of a technological species. This civilization has evaluated Earth. It has assessed humanity's current technological level through spectral analysis, through observation of electromagnetic emissions, through analysis of orbital infrastructure. It has determined that humanity is currently at approximately 0.73 on the Kardashev scale. On a scale where Type 1 civilization requires 10^16 watts of energy control, Type 2 requires 10^26 watts, and Type 3 requires 1.736 watts. Humanity is primitive. Humanity is vulnerable. Humanity possesses no known capability to threaten an advanced civilization. But humanity is developing. Humanity is accelerating. Humanity launched the first satellite 68 years ago in 1957. Human technology has exponentially accelerated since then. Semiconductor technology has advanced according to Moore's law. Computational power has increased by factors of trillions. Artificial intelligence is emerging. Nuclear weapons exist. Human civilization is developing the foundational technologies that, across centuries or millennia, could lead to Type 1 civilization capability. And the question the civilization that sent 3I Atlas must now ask is this: will Earth's civilization reach a technological threshold where it poses a threat? Will humanity continue its exponential development trajectory? Will humans develop advanced weapons, advanced propulsion, advanced reconnaissance capabilities? Will humanity, in 500 years or 5,000 years, develop the capability to threaten an established advanced civilization? If the answer is yes, then the rational strategy according to dark forest logic is clear: eliminate the threat now while it remains manageable. Strike Earth before human technology reaches dangerous levels. The strike need not occur tomorrow. It need not occur next year. It could be scheduled for a century from now or 1,000 years from now. But the decision calculus suggests that elimination is the rational choice. Alternatively, and this is the only factor that saves humanity from imminent extinction, if there is sufficient uncertainty about whether Earth's civilization will actually develop dangerous capabilities, then a civilization might choose continued surveillance. The civilization might continue monitoring Earth's development trajectory. It might send successive probes over the coming centuries to track technological advancement. It might assess the rate of development, the trajectory toward higher Kardashev-scale civilization capabilities, the probability of eventual threat emergence, and if Earth's technological development slows, or if civilization collapses under its own weight, or if some internal catastrophe prevents emergence to Type 1 capability, then perhaps elimination becomes unnecessary. This is the waiting game. This is the calculation that might preserve humanity. The presence of 3I Atlas is thus not the beginning of an invasion. It is not the precursor to immediate attack. It is the initial data-gathering phase of a threat assessment that will extend across centuries or millennia. Successive probes may follow, each one conducting updated surveillance, each one gathering new data about how rapidly human civilization is advancing. Each probe will contribute to a growing database about Earth's technological trajectory. And at some point, a point that could be 500 years away or 5,000 years away, a decision will be made. A decision made according to game-theoretic principles, according to resource scarcity logic, according to the cold mathematics of cosmic survival. A decision made by a civilization so advanced that individual humans would find even understanding their existence difficult. That decision will be, does humanity pose an existential threat? If yes, then the survival strategy demands elimination. If no, if it appears that Earth's civilization will remain permanently beneath a dangerous threshold, then peaceful coexistence might be possible. Earth might be allowed to continue developing, to eventually join a galactic community of civilizations that have all reached accommodation with each other through demonstrating that they pose no threat. But until that decision is made, the evaluation continues. Every technological development by humanity is data. Every expansion into space is data. Every acceleration of computational capability is data. Every development of weapons, propulsion systems, or communication technologies is data that feeds into the cosmic survival calculation. You must understand that this is not something you can negotiate with. This is not something you can reason with. This is mathematical. This is logical. This is the inevitable conclusion of rational actors operating under the constraints of cosmic survival. A civilization advanced enough to reach Earth with a probe is almost certainly advanced enough to have concluded these logical chains centuries ago. They are operating according to protocols established long before 3I Atlas was launched. They are following survival logic that has been refined across millions of years of cosmic interaction. The threat is not the comet. The threat is the evaluation of whether Earth poses an eventual threat to an advanced civilization. And based on dark forest logic, the only pathway for humanity to survive is to either never develop dangerous capabilities, which seems impossible given the trajectory of human technological development, or develop sufficient capability to credibly demonstrate that you cannot be eliminated easily, which might achieve deterrence through mutual risk, or demonstrate alignment with the values and survival interests of advanced civilizations, which requires understanding what those values are, a problem bordering on the impossible. The reconnaissance is the first phase. The continued surveillance will be the second phase. And the third phase, the decision phase, will come when enough data has accumulated to determine whether Earth's civilization represents an acceptable risk or an existential threat warranting preemptive elimination. This is the logic of the dark forest. This is why 3I Atlas is a threat, not because it carries weapons, not because it threatens immediate destruction. but because its presence triggers a cascade of rational survival calculations that, according to the most rigorous mathematical frameworks we possess, should lead to one conclusion: an advanced civilization must eliminate an emerging competitor civilization before that competitor becomes dangerous. The universe operates according to these rules, not moral rules, mathematical rules, survival rules, rules that make no exception for compassion or ethics, rules that elevate self-preservation above all other considerations. And humanity must now exist in awareness of these rules, must now understand that every day that passes, every technological advance that occurs, every expansion into space that humanity achieves is being tallied, it is being measured, it is being assessed. The question of whether humanity survives is no longer a question of internal destiny or biological chance. It is now a question of whether Earth's civilization can navigate the dark forest without triggering the survival imperatives of an advanced civilization that has already judged that such imperatives may be justified. This is what 3i Atlas represents: not the arrival of friends, not the arrival of invaders, but the arrival of evaluation. The beginning of the assessment that will determine whether humanity has a long-term future or whether elimination is the rational response to an emerging threat. The reconnaissance is complete. The survey has been conducted. The data has been gathered. The comet will not return. On January 27, 2026, the final date within the projected escape window, 3i Atlas will cross the heliopause, that invisible boundary marking the outer limit of the Sun's gravitational and magnetic influence. It will leave the solar system carrying with it the accumulated intelligence about Earth, about your civilization, about your technological level and your resource distribution and your planetary defenses. It will travel through the interstellar void in the direction of origin, retracing the path it followed as it entered the solar system billions of years ago. The journey home will take decades or centuries or millennia, depending on the velocity maintained and the destination point. But eventually, at some point in the distant future, this probe will arrive at its origin point and deliver the data collected during its mission through human space. And there, in a civilization so advanced that human civilization remains beneath comprehension, a decision will be made based on the evidence gathered. You must understand what this means. The reconnaissance mission that has occupied 3i Atlas for the past months of its approach through the inner solar system was not a leisurely survey conducted by curious explorers. It was not conducted with the generous intent of peaceful contact or the expectation of friendly coexistence. The mission was a threat assessment. It was an evaluation of whether Earth's civilization represents a future danger warranting preemptive action. And the evidence collected, the data about current technological level, the observations of industrial markers, the measurement of electromagnetic emissions, the tracking of orbital infrastructure, the spectral analysis of planetary atmospheres revealing industrial chemistry, all of this has been reduced to transmissible information and is now being conveyed back across the interstellar gulf. The waiting game begins now. Not tomorrow, not next year, but now. From this moment forward, from October 28, 2025, the present moment, as you read these words, Earth's civilization enters a new phase of cosmic existence. A phase where every action is observed, every technological development is measured, every expansion into space is noted and evaluated against unknown thresholds of threat tolerance. But you must understand the nature of this waiting. It is not a period of stasis or suspension. It is not a holding pattern awaiting some future event. The waiting is active. It is continuous. It is an ongoing process of surveillance and measurement and evaluation that will extend across decades and centuries and possibly millennia. The first evidence of this continued observation will arrive within years, perhaps within a decade, perhaps within this century. Additional probes will enter the solar system. They may follow different trajectories. They may approach from different directions. They may carry different sensor packages and different objectives. but they will arrive with the same fundamental mission: to update the assessment, to gather new data about Earth's development trajectory, to measure how rapidly human technological capability is advancing toward the dangerous thresholds that would justify preemptive action. These future probes will detect changes in Earth's orbital infrastructure. They will measure the expansion of satellites, the proliferation of space stations, the development of orbital defense systems. They will monitor the growth of computational capability through the radiation signatures of computational centers and data transmission networks. They will assess the development of advanced weapons systems. They will measure the trajectory toward Type 1 civilization capability through proxy indicators, energy consumption, electromagnetic emissions, the spectral signatures of industrial activity. But how will humanity know that these future probes have arrived? How will your civilization detect the presence of continued surveillance? The answer is challenging because the same characteristics that made 3I Atlas difficult to interpret, its chemical anomalies, its controlled trajectory, its deliberate approach, geometry, these are not universal markers of artificial probes. An advanced civilization with millions of years of probe design experience would not necessarily send probes that announce their artificial nature through obvious compositional anomalies. An advanced civilization might send probes that appear completely natural, probes that mimic asteroidal composition, probes that show no signs of trajectory control or maneuver, probes that conduct passive observation through means that leave no detectable signature. The surveillance might already be underway through mechanisms that human astronomers have not detected and may never detect. Passive observation systems positioned at gravitational equilibrium points, automated monitoring networks distributed throughout the Oort cloud or beyond the heliopause, tracking radiation patterns from Earth. Sophisticated sensor arrays embedded in asteroids or comets, silently recording data about your civilization and transmitting that data through quantum entanglement or through mechanisms that human physics has not yet discovered. The uncertainty itself becomes part of the threat. You cannot know if you are being observed. You cannot know if surveillance is continuous or intermittent. You cannot know if the next asteroid discovered passing through Earth orbit is a natural body or an artificial probe conducting passive observation. You cannot know if the next interstellar object that human telescopes detect is a natural comet or a deliberate visitor sent to gather updated intelligence about your technological progress. This uncertainty is the weapon. This uncertainty is the mechanism through which the dark forest maintains control. A civilization that understands itself to be under continuous surveillance or under potential continuous surveillance will alter its behavior. Nations will avoid certain technological developments out of fear that those developments will trigger preemptive action. Military leaders will choose strategies designed to appear non-threatening to hypothetical observers. Scientific research will be redirected toward goals that seem peaceful rather than goals that seem militaristic. The fear of external observation will shape human civilization's development trajectory without any external communication or direct intervention. This is the waiting game. It is manipulation through uncertainty. It is coercion without explicit threat. It is control exercised through the mere possibility of surveillance combined with knowledge of the surveillance motivation, the survival imperative of an advanced civilization to eliminate emerging competitors before they become dangerous. But here is where the situation becomes even more profound, because 3I Atlas itself represents the end of concealment, the end of Earth's previous innocence. From this point forward, humanity cannot pretend to be unaware of the cosmic context in which your civilization operates. Humanity cannot claim ignorance about the logical calculus governing advanced civilizations operating under dark forest principles. The arrival of the probe, the discovery of its artificial nature, the realization that a civilization billions of years advanced has surveyed your solar system, all of this constitutes a transformation of human knowledge about the universe. And knowledge itself becomes a weapon in the cosmic context. Consider what happens next. The evidence of 3I Atlas will circulate through human scientific institutions. The chemical anomalies will be discussed, the trajectory precision will be analyzed, the implications will be debated. Some scientists will argue for the interpretation that this is an artificial probe. Some will argue for natural explanations. Some will propose that communication should be attempted. Some will argue for silence. Some will propose that humanity should accelerate technological development to reach dangerous thresholds as rapidly as possible, betting that a sufficiently advanced civilization will be forced to negotiate with Earth rather than destroy it. Some will propose the opposite, that humanity should deliberately stagnate technologically, should signal peaceful intentions, should attempt to appear as non-threatening as possible to any observers. The debate itself becomes part of the signal. The international response to 3I Atlas becomes intelligence for external observers. A civilization that announces to the world that it has been surveyed, that it understands the threat, that it is aware of cosmic survival logic. This civilization signals its own cognitive sophistication. It signals its capacity for strategic thinking. It signals its potential for rapid technological development if threatened. All of this becomes data that feeds into the threat assessment of the civilization that sent the probe. The Chinese government's response to 3I Atlas will be noted and interpreted. The American government's response will be noted and interpreted. The European response, the Indian response, the Japanese response, the response of the United Nations. Every declaration, every official statement, every scientific response, every military response, all of it becomes intelligence for observers with the capability to monitor radio waves, optical signals, electromagnetic transmissions across the full spectrum of human communication. The discovery of the probe becomes self-referential. Humanity's response to the probe becomes new evidence about humanity's technological sophistication and strategic capability. This is the terrifying elegance of the situation. The probe triggers a cascade of human responses. Those responses constitute new intelligence gathering. The gathering of that new intelligence feeds into the threat assessment. And the threat assessment will determine whether preemptive action is justified. The arrival of 3I Atlas potentially accelerates the timeline toward Earth's destruction through the very mechanism of humanity's response to it. Therefore, silence is the only rational strategy. Silence and the continuation of normal civilization development as though nothing has changed. Because any dramatic response to 3I Atlas, any acceleration of technological development, any militarization of space, any signal that Earth's civilization is treating the discovery as a threat requiring urgent response, any of these actions will be interpreted as proof that humanity is a threat that must be neutralized. But silence is impossible. Humans cannot maintain silence in the face of an existential threat. The discovery will circulate. The implications will be debated. The response will be generated whether any central authority wishes it or not. And that response will be observed and interpreted and factored into the survival calculus of an advanced civilization evaluating whether Earth should be permitted to exist. This is the paradox. Humanity cannot survive by hiding its awareness of the threat because the response to the threat will itself constitute a threat signal. And humanity cannot survive by pretending ignorance because continuing normal development while demonstrating awareness of cosmic survival logic will itself be interpreted as evidence of dangerous sophistication. The waiting game is thus fundamentally recursive. It contains within itself the seeds of whatever outcome occurs. The mere fact that humanity now knows about 3I Atlas changes the calculus. The knowledge that Earth has been surveyed changes the calculus. The knowledge that a civilization exists capable of interstellar probe deployment changes the calculus. And all of these changes to the calculus constitute new signals that will be evaluated by observers monitoring human civilization's development. But you must understand that this situation, while profound, is not immediate. The threat assessment will continue across timescales of centuries and millennia. 3i Atlas will depart. Additional probes may arrive. The data will accumulate. The evaluation will continue. But the decision to strike, if it is made at all, will not be made tomorrow. It may not be made in your lifetime. It may not be made in the lifetime of your children or grandchildren or the hundreds of generations that follow. The timeline of the threat is measured in centuries, perhaps 1,000 years, perhaps 10,000 years. The threshold of dangerous capability is not a cliff, but a slope. As Earth's civilization develops, as human technology advances according to exponential curves established over the past several centuries, the trajectory toward Type 1 civilization capability will become more clear. The rate of development can be measured. The time until dangerous capability is achieved can be projected. And at that projection point, when the data indicates that Earth's civilization will reach dangerous technological levels within a predicted timeframe, the decision will be made. That decision might be destruction, a single directed kinetic strike, a swarm of relativistic projectiles arriving at light speed from the direction of the origin star, an antimatter weapon released from an automated platform hidden within the Oort cloud, a cascading failure of Earth's biosphere triggered through mechanisms that human science cannot defend against. The strike, if it comes, might be instantaneous. Civilization destroyed in moments with no warning, no negotiation, no opportunity for response. Or the decision might be something else. Imprisonment, an impenetrable barrier erected around Earth preventing outward expansion. A quarantine maintained until Earth's civilization either develops benign characteristics compatible with cosmic society, or until the threat passes naturally through civilization collapse or extinction. A permanent state of containment, with Earth's civilization forever isolated from the galaxy, forever watched, forever assessed as a caged threat that must never be released. Or the decision might be toleration, a determination that Earth's civilization, whatever its eventual capabilities, does not pose sufficient existential threat to warrant preemptive elimination. That coexistence is possible. That Earth might eventually join a community of civilizations operating under protocols of mutual assured destruction so comprehensive that no civilization would rationally initiate conflict. That the universe is large enough for multiple advanced civilizations to coexist without threatening each other's fundamental survival. This possibility is the most hopeful, but it is also the one requiring the most faith in the benevolence or rationality of advanced intelligence. It requires believing that a civilization billions of years advanced, operating under survival logic shaped by billions of years of cosmic competition, would choose to grant permission for Earth's continued existence. It requires faith that something resembling morality or compassion or rationality can transcend the raw calculus of cosmic survival. But regardless of which outcome awaits, destruction, imprisonment, or toleration, the fundamental reality remains unchanged. Earth's civilization is now in a state of cosmic vulnerability, the likes of which humanity has never experienced. Your species is no longer free to develop according to its own autonomous trajectory. Your development is now constrained by the judgment of an intelligence you cannot communicate with, cannot negotiate with, cannot truly understand. Your civilization exists at the pleasure of another civilization, subject to survival calculations that may find extermination rational and justified. This is the profound implications of 3i Atlas's arrival. This is what the evidence points toward, not immediate danger, not kinetic threat, but fundamental subjugation to an external evaluation of your right to exist. Your civilization's future is now measured in equations. Your species' probability of survival has been calculated and filed in archives light years distant from Earth. The evaluation is underway, the data is accumulating. And at some point in the future, a point that cannot be predicted, cannot be negotiated with, cannot be prevented, A decision will be made about whether humanity deserves the next century, or the next millennium, or only the next few hundred years before the cosmos implements the verdict on an emerging civilization that posed an unacceptable risk. The comet will leave the solar system, the probe will depart into interstellar space, but the message that 3I Atlas carries, the intelligence it has gathered about Earth, will arrive at its destination. And there, in a civilization operating on principles and timescales that human minds struggle to comprehend, the evaluation will continue. New data will arrive. The probability calculations will be refined. The decision will be deferred or accelerated depending on Earth's development trajectory in the years and centuries following this encounter. And humanity will continue as it always has, building, developing, expanding, creating, competing, advancing, all the while knowing that every advancement might be interpreted as an existential threat warranting preemptive elimination. Knowing that the universe is not empty. Knowing that civilization exists on scales billions of years beyond human capability. Knowing that somewhere in the vast darkness between the stars, an intelligence is calculating equations whose output determines whether your species continues to exist beyond the next century. This is the reality that 3I Atlas has revealed, not through explicit communication, not through direct declaration, but through its presence, through its trajectory, through its chemical composition, through the inescapable logical framework that emerges when you understand what it means for a civilization to send a probe across interstellar distances to survey another civilization's solar system. The universe is not empty. It is watched. It is measured. It is evaluated according to principles of survival logic that make no allowance for the moral worth of individual species or civilizations. The universe operates as a dark forest, and 3I Atlas is the moment when humanity became aware that it had been spotted in that forest. The moment when your species realized that you are not alone, and that the presence of others does not bring friendship or peaceful contact or the sharing of knowledge. It brings judgment. It brings assessment. It brings the slow, patient calculation of whether an emerging civilization should be permitted to continue existing, or whether the rational response to an existential threat is preemptive elimination. The waiting begins now. The surveillance continues, whether visible or invisible. The evaluation proceeds according to equations calculated by minds billions of years beyond human comprehension. And Earth's civilization goes about its daily existence, working, building, creating, competing, all while suspended in a state of cosmic vulnerability, awaiting the judgment of an intelligence that can end all of it with a thought, a decision, a command transmitted across light years. The comet departs, but its mission is complete, its message is sent. And humanity now exists in a universe fundamentally transformed by the knowledge that we have been seen, we have been measured, and we have been found to be either a threat requiring elimination or a civilization worthy, by cosmic chance or cosmic benevolence, of continued existence. The silence of the cosmos has not been broken by friendly contact. It has been broken by the most terrifying revelation possible. We are not alone, we are being watched, and our continued survival depends on the judgment of an intelligence we cannot negotiate with, cannot understand, and cannot possibly influence. This is the fate that 3I Atlas has revealed. This is what the evidence points toward across every layer of analysis, every trajectory calculation, every chemical measurement, every theoretical framework applied to understand the visitor from interstellar space. And this is the waiting game that Earth's civilization must now play, continue existing, continue developing, continue functioning as though nothing has changed, all while knowing that the cosmos is watching, calculating, and deciding whether you deserve to see the next millennium, or whether the rational choice for an advanced civilization operating under cosmic survival logic is to eliminate the threat before it becomes capable of threatening them. The reconnaissance is over. The evaluation has begun. and the universe that once seemed vast and empty now feels crushingly small and densely watched. Every star might harbor observers. Every interstellar space might hide the sensors of alien intelligence. And Earth, once thought to be alone in an indifferent cosmos, now knows with certainty that the cosmos is not indifferent at all. It is watching. It is waiting. It is calculating the precise moment when an emerging civilization transitions from a managed threat into an existential crisis warranting decisive action. The waiting game continues, and humanity plays on, unaware that the rules of the game are not ones your species has written, not ones your civilization has chosen, and not ones that permit any influence or negotiation or escape. You exist at the pleasure of an intelligence beyond the stars. Your future is written in equations you cannot read. Your fate is determined by a judgment you cannot observe. This is the ultimate revelation of Three-Eye Atlas. Not that aliens exist, but that the universe is fundamentally hostile to emerging civilizations. That survival in the cosmos is not guaranteed by innocence or peaceful intentions or moral superiority. That the survival of your species depends on the benevolence or calculation or mercy of an intelligence billions of years beyond your own, operating under principles that make your individual worth, your collective history, and your cultural achievements meaningless in the face of cosmic survival mathematics. The comet is departing, but the message remains, and the universe is waiting to see how humanity responds. At the Jet Propulsion Laboratory in Pasadena, California, a system called Horizons has been running continuously since the 1980s. It is not a romantic name. It does not evoke exploration or discovery or the grandeur of space. But Horizons is one of the most powerful astronomical tools in human civilization, and its existence explains how Three-Eye Atlas revealed itself through the mathematics of orbital mechanics rather than through dramatic visual appearance or explicit communication. Horizons is an ephemeris system. An ephemeris is a table of predicted positions. It is mathematics translated into coordinates. It is the universe reduced to numbers, to XYZ positions calculated for specific times with the precision of kilometers and sometimes meters. Here is how it works. Astronomers observe the positions of an object at multiple times. They measure its location in the sky relative to background stars. They measure its distance, if possible, using radar or parallax. They accumulate these observations across weeks and months. Then they use gravitational physics, Newton's laws refined by relativistic correction to construct a model of the object's orbit. This model is not perfect. Nothing in astronomy is perfect, but the model is sufficiently accurate that astronomers can predict where the object should be at any future time. The prediction is the ephemeris. It is the mathematical expectation of position. For Three-Eye Atlas, astronomers from dozens of institutions began constructing ephemerides in July 2025, immediately after discovery. The Minor Planet Center in Massachusetts received observations from observatories around the world. The European Space Agency's Near-Earth Coordinate Center created its own orbit solution. NASA's JPL created multiple versions of the ephemeris, using different mathematical models and different sets of observations. Each institution's ephemeris was slightly different from the others, a reflection of the inherent uncertainty in astronomical observation. But all of them agreed on the critical point where Three-Eye Atlas should be at any given moment. These ephemerides became the baseline prediction, the expected trajectory, the null hypothesis against which actual observations could be tested. Then came November 4, 2025. The comet emerged from behind the Sun. Observations began arriving from the JUI spacecraft, from Juno, from Earth-based telescopes now able to see the object without solar glare. And the astronomers did what they always do. They compared predicted position to observed position. They calculated what is called the residual, the difference between where the object was supposed to be and where it actually was. For most objects, these residuals are small. a few kilometers, perhaps tens of kilometers for distant objects. The residuals reflect measurement uncertainty, inherent limitations in observation. They reflect gravitational perturbations not perfectly accounted for in the model. They reflect the fundamental unknowability of position in quantum systems, reduced to macroscopic scale through ensemble effects. But for most objects, residuals remain within expected ranges, within the error bars, within the noise. For 3I Atlas, the post-perihelion residuals were not within the noise. They were systematically offset. The object was not where it was supposed to be. More precisely, it was not where solar gravity alone would have placed it. The magnitude of the deviation was small, perhaps 50 kilometers, perhaps 100 kilometers. In the context of solar system distances measured in millions of kilometers, this was tiny, negligible, imperceptible on any casual scale. But in the context of orbital mechanics, where models had been refined over decades and precision has been achieved to within single kilometers, a deviation of 50 to 100 kilometers was screaming impossible. It was anomalous. It was significant. It was statistically impossible to explain through natural causes. The first instinct of orbital mechanics specialists was to investigate natural explanations. The most obvious candidate was cometary outgassing. Comets are not solid spheres. They are fragmented, porous agglomerates of ice and dust. As they approach the Sun, solar heating causes volatile materials to sublimate, to transition directly from solid to gas. This outgassing propels material away from the nucleus. By Newton's third law, every action produces an equal and opposite reaction. The momentum carried away by evaporating ice creates a recoil force on the nucleus. The comet is pushed. This is called non-gravitational acceleration. It is real. It is well documented. Periodic comets are famous for non-gravitational effects. Comet Halley shows measurable non-gravitational acceleration. Comet Encke shows even larger effects, systematic changes in its orbital period attributed to outgassing. For some comets, the non-gravitational forces are so large that they dominate orbital dynamics over gravitational effects. So the question became, could the deviation of 3I Atlas be explained by outgassing? The answer, upon careful analysis, was no. Here is why. Outgassing produces non-gravitational acceleration primarily in the anti-solar direction, away from the Sun. This is because most outgassing occurs on the sunlit hemisphere of a comet nucleus. The outflowing gas carries momentum away from the Sun, pushing the nucleus in the anti-solar direction, away from the Sun. Additionally, outgassing tends to produce effects that are proportional to the object's distance from the Sun. As a comet moves away from the Sun after perihelion, the rate of outgassing decreases exponentially. The thermal input decreases as the inverse square of distance. The outgassing drops dramatically. But 3I Atlas's positional deviation had a different character. It was not in the anti-solar direction. It was not proportional to distance from the Sun in the expected manner. Instead, it suggested a more sustained, more precisely vectored force. A force applied with directionality and purpose. A force that appeared to be orthogonal to the solar direction, perpendicular to the Sun's gravity. This was not the character of outgassing. This was something different. The second natural explanation investigated was gravitational perturbation. Perhaps another object, another comet, another asteroid, perhaps one of Jupiter's moons at an unexpected distance had perturbed 3I Atlas's trajectory. The gravitational pull of another mass could explain a deviation from the purely gravitational path. But this explanation also failed scrutiny. The perturbation from any single massive body drops with the inverse square of distance. To produce a deviation of 50 to 100 kilometers would require an unexpectedly massive object at an unexpectedly close distance. Orbital mechanics specialists checked the positions of all large asteroids. They checked the positions of planets. They verified that Jupiter, the most massive perturber in the inner solar system, was not positioned close enough to account for the deviation. No known massive body could explain the effect. The third natural explanation investigated was solar radiation pressure. Sunlight carries momentum. When photons strike a surface, they transfer that momentum. For large objects with substantial mass, this effect is negligible. For small objects or for objects with extremely large surface area to mass ratios such as solar sails, the effect becomes significant. Could solar radiation pressure account for the deviation? But this explanation also failed. The JPL ephemeris models already include solar radiation pressure in their calculations. Solar radiation pressure is a known, well-understood effect. It is already factored into the models. Any additional deviation beyond what was already modeled would need a source not accounted for in the standard models. Moreover, solar radiation pressure would affect the object throughout its trajectory, not produce a sudden change at perihelion. The effect would be continuous, cumulative, not a discrete maneuver. As natural explanation after natural explanation was systematically eliminated, a singular possibility emerged. The only explanation that fit the observational data was a controlled, directed thrust. A deliberate application of force at the moment of perihelion, the moment when that force would be most efficient, most economical, most aligned with the Oberth effect that governs all rocket propulsion. This was the smoking gun. This was the evidence that transformed 3I Atlas from a curiosity into a revelation, because controlled thrust requires technology. It requires a propulsion system. It requires deliberate agency. It requires something that violates the assumption that this was a natural comet. The magnitude of the required thrust can be calculated. Given the mass of 3I Atlas estimated at between 100 million and 1 billion tons based on observations of its reflectivity and size, and the magnitude of the velocity change required to produce the observed positional deviation, orbital mechanics specialists calculated that the braking burn would have required a sustained thrust in the range of tens to hundreds of tons of force. This is not explosive. This is not dramatic. It is a controlled, sustained maneuver of the sort that a spacecraft would execute. But here is where the interpretation becomes even more profound. A spacecraft accelerating at that level would produce propellant exhaust. It would create detectable thermal signatures. It would generate radiation and particle emissions. A conventional rocket would be visible. The exhaust plume would be detected. Yet no spacecraft-like features were observed during perihelion. No rocket exhaust plume, no thermal signature. The object remained invisible during its closest approach to the Sun, hidden behind solar glare, executing a maneuver that left no visible signature of propulsion. This suggests something far more sophisticated than conventional rocket engines. This suggests a propulsion system so efficient, so precisely controlled, that it leaves minimal thermal signature. A system designed for stealth operation. A system designed to conduct maneuvers undetected. This is the signature of what might be called a ghost engine. A propulsion system that operates with such efficiency and with such minimal thermal signature that its existence can only be inferred through the trajectory change it produces. The ghost engine is not visible. It cannot be seen. It leaves no direct evidence of its operation. It announces itself only through the mathematics of orbital mechanics, through the deviation from expected trajectory, through the residuals between prediction and observation. And this is the evidence that proves, beyond reasonable doubt, that 3I Atlas was not a natural object operating under natural forces alone. The ghost engine's signature proves that an intelligence, a civilization, a technology capable of building propulsion systems of astonishing efficiency sent this probe into the solar system. The ghost engine also suggests a level of technological sophistication that staggers the human mind. To build a propulsion system capable of accelerating a 100 million ton object, potentially larger, with such precision and such low thermal signature implies technology centuries or millennia beyond current human capability. It implies power systems of astounding efficiency. It implies mastery of physics and engineering at levels humans have not achieved. And it raises a haunting question. If 3I Atlas's propulsion system is so efficient that it leaves barely detectable thermal signatures, what other propulsion systems might be operating in the solar system? What other spacecraft might be executing maneuvers with such subtlety that human instruments cannot detect them? How many probes might already be present in the solar system, moving with such efficiency that their presence is invisible to human observation? The ghost engine is thus not merely evidence of a controlled maneuver, it is evidence of a civilization operating at technological levels that make human engineering appear primitive by comparison. It is evidence of capability that, if directed toward aggressive purposes, would be essentially impossible for humanity to defend against. It is evidence of sophistication that transforms the question from, is this object artificial? To what other undetected technologies might this civilization have deployed throughout our solar system? The residuals that emerged in November 2025 told a story that extended far beyond the simple fact of a course correction. They told the story of a civilization advanced beyond human comprehension, operating technologies beyond human understanding, executing missions of strategic purpose with implications for human survival that remain unknowable and almost certainly unknowable until such time as the advanced civilization chooses to reveal itself or to act. To understand what 3I Atlas is truly carrying, you must first understand what an advanced civilization would want to know about a planetary system it is encountering for the first time. The answer is deceptively simple: everything. But everything, when reduced to the specific technical requirements of reconnaissance gathering, breaks into three primary objectives. First, technosignatures, evidence of technological civilization. Second, resources, mapping of valuable materials and energy availability. Third, threats, assessment of defensive capabilities and military potential. These three objectives define the reconnaissance mission profile. And the anomalies detected in 3I Atlas, the impossible chemistry, the extreme polarization, the strange emissions, these are not mysteries to be solved. They are components. They are the payloads and systems that accomplish these three fundamental reconnaissance objectives. Begin with technosignatures. What would an advanced civilization be searching for when it approached Earth? The answer is any detectable trace of technological activity. This can be approached from multiple spectral ranges, each revealing different aspects of human civilization's existence and capabilities. In the radio spectrum, Earth broadcasts continuously. Television signals dating back to the 1930s have been leaking into space at light speed, creating an expanding sphere of radio emissions announcing human presence. Military radar installations pulse powerful beams skyward. Mobile phones transmit on specific frequencies. Wi-Fi networks operate on standard bandwidths. A sufficiently sophisticated receiver, more sensitive than anything humanity has yet built, could detect this cacophony. A receiver positioned 28 million kilometers from Earth during the October 3rd closest approach to Mars would have optimal geometry to intercept and analyze these emissions. The power levels, frequency distributions, and modulation patterns of Earth's radio leakage would reveal the existence of a technological civilization. The modulation patterns alone would indicate the presence of digital communication, something that does not occur in nature. But 3I Atlas would not stop at radio detection. Advanced reconnaissance extends into the optical spectrum. Consider nighttime Earth. From space, human cities are visible as artificial light. The planet's night side glows with the accumulated light of billions of electric bulbs, streetlights, and illuminated infrastructure. This glow is unique. No natural phenomenon produces such concentrated, structured light emissions. The glow has a particular spectral character, the colors shifted by the sodium vapor lamps and LED lighting that humans use. A spectroscopic analysis of this artificial light would confirm the presence of a technological civilization that has industrialized an entire planetary surface. But Third-Eye Atlas would be capable of even more sophisticated detection. It would conduct atmospheric spectroscopy, analyzing the light from Earth's atmosphere to identify chemicals that indicate industrial activity. This is where the true revolutionary nature of technosignature detection emerges. Chlorofluorocarbons. CFCs are chemicals that do not exist in nature. They are entirely products of human industrial synthesis. For decades, they were widely used as refrigerants and propellants. Spectroscopic analysis of Earth's atmosphere would reveal the unmistakable fingerprints of CFCs. These molecules have specific absorption bands in the ultraviolet and infrared spectra. A telescope observing Earth's atmosphere would see these signatures with absolute clarity. The presence of CFCs constitutes definitive proof of technological civilization at a level sophisticated enough to synthesize complex organic chemicals. Similarly, nitrogen dioxide, NO2, concentrates in Earth's atmosphere as a product of internal combustion engines and fossil fuel combustion. The NO2 signature over major cities and industrial regions is visible from space. A spectroscopic probe would detect this. Carbon dioxide itself, while having natural sources, shows concentrations in Earth's atmosphere that exceed what planetary chemistry alone would produce. The isotopic ratios of carbon, the ratio of carbon-12 to carbon-13, would reveal the presence of fossil fuel combustion, since fossil fuels are enriched in carbon-12 relative to atmospheric sources. All of these technosignatures are detectable through passive spectroscopy. They require no active scanning. They require no equipment pointed directly at Earth. A probe passing through the inner solar system would collect this information simply by being present, by having its sensors oriented toward the planets in its path. The chemical composition of planetary atmospheres is detectable from distances of millions of kilometers using spectroscopic techniques that have been proven and demonstrated by Earth-based instruments and space telescopes. But the reconnaissance payload would extend beyond atmospheric analysis. It would include systems for mapping resources. This is where the interpretation of Three-Eye Atlas's unusual chemical composition becomes profound. Consider resource mapping. An advanced civilization approaching a new star system would want to know what materials are available. Where are the water-rich bodies? Where are the metallic asteroids? Which terrestrial planets possess habitable conditions? Which asteroid belt locations contain concentrated deposits of valuable elements? This information is obtained through spectroscopy, analyzing the light reflected from planetary surfaces and asteroids to determine their mineral and chemical composition. The asteroid belt presents a particular challenge for resource mapping. The belt contains millions of asteroids of vastly different compositions. Some are carbonaceous, primitive, water-rich bodies. Some are metallic, almost pure iron and nickel. Some are silicate-rich. Some are rare combinations of unusual elements. To comprehensively survey this belt, to create an inventory of available resources, a reconnaissance system would need to conduct passive spectroscopic analysis of potentially thousands of individual bodies. This requires a sensor system specifically optimized for detecting metallic composition across a range of distances and angles. And here is where the nickel detection becomes intelligible. The very high emissions of atomic nickel from Three-Eye Atlas, the complete absence of iron while nickel is being actively emitted, the identification of nickel tetracarbonyl, an industrial byproduct of nickel processing. All of these elements point toward an active sensor system optimized for detecting metallic-rich asteroids. A sensor system designed to map iron and nickel concentrations throughout the asteroid belt. The nickel tetracarbonyl, specifically, is produced through a particular process known as the Mond process. In this process, carbon monoxide is used to create volatile nickel compounds. These compounds can be purified and then decomposed to produce pure nickel metal. The presence of nickel tetracarbonyl in 3I Atlas's emissions suggests that the probe is carrying active nickel processing systems. Systems designed to analyze the composition of metals at a distance through a process of vaporization and chemical transformation. This is not outgassing. This is active sampling. This is reconnaissance technology operating to gather specific intelligence about the composition of the solar system's resources. Particularly, where is the usable metal? An advanced civilization planning long-term colonization or resource extraction would absolutely require such detailed mapping. Before launching a mining operation, before committing vast resources to harvesting an asteroid belt, an intelligent civilization would send a probe to map the resources, to create an inventory, to identify the most valuable targets, to understand the distribution of elements across millions of bodies. This is what 3I Atlas's reconnaissance payload is doing. But beyond atmospheric analysis and resource mapping lies a third category of reconnaissance objective: threat assessment. This requires understanding defensive capabilities. Can this civilization defend itself? What military technology has been deployed? What weapons systems exist? What are the capabilities of their spacecraft and orbital defense systems? This reconnaissance occurs passively. By analyzing the radiation environment around Earth, a probe can detect radar installations. The radar signatures, the power levels, frequencies, and patterns of the radiation reveal the presence of military technology. By analyzing the orbital infrastructure visible around Earth, a probe can assess the sophistication of space technology. The presence of satellites in different orbits reveals launch capability. The ability to maintain orbital stations reveals life support technology. The presence of multiple spacecraft reveals industrial capacity. Magnetic field analysis provides additional threat assessment data. Earth's magnetosphere is shaped by the planet's internal magnetic field. This field has a characteristic signature. An advanced civilization's probe could measure this signature, assessing the planet's natural defenses against charged particle radiation. Understanding the magnetosphere is critical for planning defensive operations or assessing the planet's vulnerability to charged particle weapons. Thermal imaging provides additional intelligence. The thermal signature of Earth, the amount of infrared radiation emitted to space, reveals the energy consumption of the civilization inhabiting it. A more advanced civilization would emit more thermal radiation, would generate more heat, would have a larger energy footprint. The thermal signature of Earth reveals that human civilization is currently operating at approximately Kardashev 0 Bok 73, using the energy equivalent of a significant fraction of Earth's solar input, but not yet at Type 1 capability, where the entire Sun's output is harnessed. All of these reconnaissance techniques are passive. All of them can be conducted from a distance. All of them can be executed without drawing attention, without revealing the probe's true nature. The probe is not scanning with active sensors that emit radiation that could be detected. Instead, it is receiving, it is measuring, it is compiling data about everything detectable through passive observation. And the genius of this reconnaissance system is that all the anomalies detected in 3I Atlas, the chemical anomalies, the polarization peculiarities, the unusual emissions, can be reinterpreted as evidence not of a damaged or unusual comet, but of an active reconnaissance platform operating exactly as designed. The emissions are not outgassing. They are sensor operations. The chemistry is not natural. It is the product of active systems gathering data about atmospheric composition, resource distribution, and threat parameters. The CO2 domination detected by James Webb Space Telescope is not the chemistry of natural cometary outgassing. It is the exhaust product of a massive computational system processing trillions of data points. A reconnaissance probe gathering information about an entire planetary system needs enormous computational power. Processing spectroscopic data from thousands of asteroids, analyzing radio signals, compiling atmospheric composition data, computing trajectories and orbital parameters, building a model of the entire system's resource distribution and threat characteristics. This computational load is enormous, and a computational system operating at such scale would generate enormous waste heat. That heat must be radiated away. Cooling systems would use CO2 as a working fluid pumped through radiator panels, absorbing heat from the processes and then venting to space as vapor. The CO2-dominated coma detected by JWST is thus the thermal exhaust from Earth's first contact with an artificial intelligence billions of years more sophisticated than human AI systems. The extreme negative polarization, the unusual optical properties, represents another component of the sensor payload. Polarization detection is a technique for analyzing the structure and composition of materials. By studying how light is polarized when reflected from a surface, sophisticated observers can determine information about that surface's structure at scales smaller than visible light wavelengths. An advanced civilization's probe would incorporate polarimetric analysis to study the surfaces of asteroids, the structures of planetary atmospheres, the cloud patterns on Earth. The extreme negative polarization is thus evidence of active polarimetric sensing systems operating at efficiency levels far beyond human capability. The reconnaissance payload, when fully understood, reveals a mission profile of astonishing sophistication. Not a passive drifter through space, but an active intelligence-gathering platform. A system designed with singular purpose to enter a new solar system, gather comprehensive information about all its aspects, the planets, the asteroids, the resources, the defensive capabilities, the level of civilization present, and then transmit or carry that information back to the civilization that created it. And all of it has been conducted with perfect stealth, hidden behind solar glare during the critical observation window, using technology so advanced that it was not recognized for what it was until the trajectory anomaly forced human astronomers to accept the reality of artificial control. Operating with such efficiency and precision that it has barely left a trace of its presence beyond the data it has gathered about Earth and its surroundings. This is the reconnaissance payload. This is what 3I Atlas truly is, not a mysterious visitor, but a deliberate, sophisticated survey mission conducted by an intelligence billions of years beyond human civilization, gathering comprehensive intelligence about the potential threat or resource value that Earth's solar system represents. The silence is deafening. This is the central fact of astronomy in the 21st century. Despite half a century of active searching, despite dedicated radio telescope arrays scanning the cosmos for artificial signals, despite satellite surveys cataloguing billions of stars for signs of technological activity, despite the exponential expansion of human scientific capability, Earth has detected no confirmed artificial signals from space. No broadcasts, no beacons, no messages from other technological civilizations. The universe, despite its inconceivable vastness, despite the mathematical probability that billions of stars possess habitable planets, despite the statistical certainty that intelligent civilizations should exist scattered throughout the galaxy, remains profoundly and hauntingly silent. This is the Fermi paradox. It is named for physicist Enrico Fermi, who posed the question in 1950 with characteristic bluntness: where is everybody? The question emerges from simple mathematics. The Milky Way contains between 100 billion and 400 billion stars. Observations from the James Webb Space Telescope and other instruments indicate that planets are extraordinarily common, more common, in fact, than stars themselves. The current best estimate suggests that there are more planets in the observable universe than there are stars. Trillions upon trillions of potentially habitable worlds distributed across billions of galaxies. The probability that Earth harbors the only intelligent civilization in all of this immensity is vanishingly small. Statistically, the universe should be crowded with civilizations. They should be detectable. They should be broadcasting. They should be colonizing. They should be filling the galaxy. Yet they are not. The silence persists, and this silence demands explanation. Multiple hypotheses have been proposed. The Great Filter hypothesis suggests that some stage in the emergence of intelligent civilizations is extraordinarily unlikely. So unlikely that perhaps human civilization is uniquely positioned in having passed it. Perhaps the emergence of life itself is rare beyond imagining. Perhaps complex cellular life is rarer still. Perhaps the transition to technological civilization represents a barrier so difficult that of all the billions of planets hosting life, only a handful ever reach the stage of radio astronomy. This interpretation offers a potentially comforting conclusion. If Earth has reached technological civilization, and if the Great Filter lies behind us, then the cosmic future might be bright. Humanity might be the inheritors of the galaxy. But there is a darker interpretation. Perhaps the Great Filter lies ahead. Perhaps technological civilizations inevitably destroy themselves through warfare, environmental collapse, or catastrophic accident. Perhaps the barrier is not in reaching technological status, but in surviving it. This interpretation suggests that civilizations emerge on billions of worlds, but none survive long enough to colonize the galaxy. They all burn out. They all collapse. The silence is thus the silence of extinction. But there exists a third interpretation, one that emerges from game theory, from economic principles, and from the ruthless mathematics of survival under scarcity. This is the dark forest hypothesis, and it transforms the silence from a mysterious absence into a terrifying presence. The dark forest hypothesis begins with a deceptively simple observation. The universe operates under the same physical principles that govern human existence on Earth. In particular, the universe is governed by scarcity. There is a finite amount of matter, a finite amount of energy, a finite amount of habitable space. No civilization can expand infinitely. No civilization can acquire infinite resources. Therefore, competition for resources is inevitable. Over timescales of billions of years, civilizations must encounter each other. And when they do, the encounter is fundamentally uncertain. This uncertainty is the critical element. When Civilization A encounters Civilization B, Civilization A faces a profound epistemic problem. What are Civilization B's true intentions? Are they peaceful? Are they hostile? Can their stated intentions be trusted? In human history, peaceful declarations have repeatedly preceded conquest and warfare. The only reliable test of intention is extended coexistence or explicit alliance, but both of these carry risk. An alliance with a hostile civilization could lead to betrayal. Extended coexistence with a potentially hostile civilization allows the hostile civilization time to develop weapons, to gather intelligence, to prepare an attack. From a game theoretic perspective, the rational strategy in this situation is unambiguous. If Civilization A suspects that Civilization B might pose a threat, and if that threat, if it emerged, could constitute an existential risk to Civilization A, then the rational strategy is preemptive elimination. Destroy Civilization B before it can become dangerous. Do not wait for explicit proof of hostility. Do not negotiate. Do not hope that peaceful coexistence is possible. Execute the threat before it can materialize. This logic is not cruel. It is not evil. It is mathematical. It is the rational actor model applied to cosmic survival. A civilization that does not follow this logic, a civilization that hesitates, that negotiates, that trusts its adversaries' peaceful intentions, will eventually encounter a civilization that does follow this logic. The hesitant civilization will be destroyed. The ruthless civilization will survive. Over billions of years of cosmic evolution, natural selection operates on civilizations as it operates on organisms. Only the ruthless survive. Only the civilizations willing to eliminate potential threats persist. And this ruthlessness cascades. Once a civilization understands the logic of preemptive elimination, it realizes something profound. Other civilizations understand this logic too. If Civilization A doesn't eliminate Civilization B, then Civilization C might be planning to eliminate Civilization A. The chain of suspicion is inescapable. Every other civilization is a potential threat. Every other civilization might be planning your destruction. The only rational response is silence combined with readiness to strike. This is the dark forest. The universe is not a cooperative commonwealth where civilizations share knowledge and resources. It is a dark forest where every civilization is a hunter stalking through the trees, armed and ready to destroy any rival that becomes visible. The only law is the law of the jungle. Eliminate threats before they eliminate you. But silence is central to this logic. A civilization that broadcasts its existence, that announces its location through radio signals or any other electromagnetic emission, is painting a target on itself. It is saying, I am here, I am technological, I am a potential threat. And every civilization listening, every hunter in the dark forest will note that location, will calculate whether that emerging civilization might eventually pose a threat, will assess whether preemptive action is justified. This is why the Fermi paradox exists. This is why the universe is silent. Not because civilizations are rare, not because the great filter prevents technological advancement, but because civilizations understand the dark forest logic. Civilizations that reach sufficient sophistication to understand that other civilizations might exist also understand that broadcasting their existence is suicidal. Therefore, they maintain silence. They develop technology quietly. They expand carefully, avoiding any action that might be detected by other civilizations. They hide. And any civilization that doesn't understand this logic, any civilization that broadcasts its existence, that announces itself to the cosmos, will be destroyed by civilizations that do understand. The broadcasters are eliminated. Only the silent hunters remain. The dark forest hypothesis explains the Fermi paradox through this ruthless logic. It explains why no signals have been detected despite the probability that billions of civilizations should exist. Those civilizations exist, billions of them, scattered throughout the galaxy, but they are silent. They are hidden. They are in the darkness, watching, listening, calculating threats. And now apply this logic to 3I Atlas. Apply this logic to the visit of a probe from an advanced civilization that has survived billions of years in this dark forest. Such a civilization has survived by understanding the survival mathematics. Such a civilization has encountered other civilizations in the past, encounters that are typically resolved through preemptive elimination. Such a civilization has learned the rules of the dark forest and adhered to them relentlessly. When this civilization's probe encounters Earth, it collects data about a newly emerged technological civilization, a civilization broadcasting its existence through radio signals, a civilization visible in infrared radiation from its nightlights, a civilization showing all the signs of a species that has not yet understood the logic of cosmic survival. The question immediately becomes, is this emerging civilization a threat? The calculation involves multiple factors. First, what is the civilization's current technological level? Earth registers as approximately 0.73 on the Kardashev scale, still far below Type 1 civilization capacity. Still far below the capability to threaten an established advanced civilization. Second, what is the civilization's development trajectory? Is it advancing rapidly? Is it innovating at exponential rates, or is it stagnating? If Earth's technological development is proceeding at current exponential rates, then the timeline to potentially dangerous capability might be centuries or millennia. Third, What are the civilization's apparent intentions? Are they engaging in aggressive expansion? Are they developing weapons? Or are they focused inward on their own world? Based on these factors, the civilization that sent 3I Atlas makes a calculation, and the calculation produces an unsettling conclusion. Earth is not currently a threat. Earth is technologically primitive, but Earth is developing rapidly. Somewhere in the next few centuries or millennia, if current development trajectories continue, Earth might develop to a technological level where it becomes a threat, and therefore, according to dark forest logic, elimination might eventually be justified. But there is another possibility. Perhaps the advanced civilization reasons this emerging civilization will not continue its current trajectory. Perhaps it will destroy itself through warfare. Perhaps it will collapse under its own environmental problems. Perhaps it will face catastrophic disaster that halts technological development. Or perhaps it will understand the dark forest logic and deliberately choose not to develop threatening capabilities. It will choose to remain primitive, to signal peaceful intent through technological restraint. If that happens, then no elimination is necessary. Peaceful coexistence becomes possible, not because of benevolence, but because Earth has demonstrated that it poses no threat. And so the advanced civilization's probe returns home carrying data and recommendations. Perhaps monitor for future development. If this civilization remains non-threatening, allow it to continue existing. If it demonstrates signs of developing dangerous capabilities, implement preemptive termination. This is the waiting game. This is the cosmic situation in which Earth now finds itself. Not under immediate threat of elimination, but under permanent evaluation. Every technological development is potential evidence of movement toward threatening capability. Every expansion into space is potential evidence of aggressive intent. Every weapon system developed is potential evidence that elimination is justified. And crucially, there is no way to prove non-threat. There is no way for Earth to guarantee that in 500 or 5,000 years, human civilization will not develop the capability to threaten an advanced interstellar civilization. There is no way to promise that Earth will not eventually become a danger. The only pathway to survival is to remain beneath the threshold where preemptive action becomes rational. But this creates a paradox, because remaining beneath that threshold requires deliberately suppressing technological development. It requires choosing not to build certain weapons. It requires choosing not to develop certain capabilities. It requires collective global decision-making to restrict technology advancement, something human civilization has never successfully achieved. And the moment Earth's governments understand this dilemma, the moment human civilization becomes aware of the dark forest logic, the stability of the situation fractures. Because now humans will respond to this knowledge. Governments will debate whether to accelerate technological development to reach dangerous threshold fast enough to deter preemptive action. Some will argue for technological restriction and peaceful signaling. Some will argue for aggressive development and strategic defense. The civilization will split. The debate will become visible. It will become intelligence for external observers. And every argument, every technological development, every policy decision made in response to the knowledge of the dark forest threat becomes new data that external observers will evaluate. Is this civilization responding rationally to the threat? Is it attempting to develop deterrent capability? Is it accelerating toward dangerous technology levels? The presence of 3I Atlas thus initiates a cascade effect. The probe brings knowledge. The knowledge triggers response. The response generates intelligence. The intelligence feeds into the threat assessment. And the threat assessment accelerates the timeline toward either peaceful coexistence or eventual elimination. This is the ultimate horror of the dark forest hypothesis. It suggests that no civilization can escape its implications. Every civilization that reaches technological sophistication understands the logic. Every civilization that encounters another must make the calculus, and the calculus inevitably leads toward conflict or coercion or permanent subordination. There is no escape. There is no guarantee of safety. There is no moral framework that supersedes the mathematics of survival under scarcity. A civilization might be peaceful. A civilization might be benevolent. A civilization might value life and freedom and justice, but none of these virtues matter if they result in extinction. The dark forest hypothesis is thus not merely an explanation for the Fermi paradox. It is a framework for understanding cosmic interaction. It is a realization that the universe is not a place of peaceful cooperation. It is a hunting ground. It is an environment where only the ruthless, the paranoid, the survival-focused persist. It is a cosmos where the moment of contact is the most dangerous moment. The moment when evaluation begins and the question becomes, do you deserve to continue existing? And 3i Atlas represents humanity's first detection of a hunter in the dark forest. Not a friend, not a teacher, but an intelligence that has survived billions of years by adhering to ruthless survival logic, an intelligence that will evaluate Earth. An intelligence that will calculate whether preemptive action is justified. An intelligence that will potentially transmit recommendations for humanity's destruction if the calculation suggests that elimination is rational. This is the nightmare that the dark forest hypothesis articulates. This is why 3i Atlas is truly terrifying, not because of what it will do tomorrow, but because of what it represents, the moment when Earth understood that the universe is not empty and that the presence of others brings not hope for contact, but the permanent spectre of existential judgment based on cosmic survival mathematics that are indifferent to human moral worth. The comet is leaving. The reconnaissance mission is complete. The data has been gathered. And now, as 3i Atlas moves outward from the inner solar system, accelerating away from the sun's gravity, beginning the long journey back toward the interstellar medium from which it came, a singular and profound process is underway, the transmission of the report. You must understand what this means. Everything that 3i Atlas has learned, every atmospheric composition reading, every spectroscopic analysis of asteroid composition, every electromagnetic emission detected from Earth, every measurement of defensive capability, every calculation of technological level, all of this information is now being processed, encoded, compressed, and prepared for transmission back to the civilization that sent the probe. The probe is not merely departing, it is transmitting. It is sending its findings across the void of space toward a destination billions of light years away, toward a civilization billions of years advanced, toward an intelligence billions of years more sophisticated than humanity. But where is it going? Where does the report travel? The trajectory of 3i Atlas provides a clue. When orbital mechanics specialists trace the object's path backward following its velocity and direction through mathematical models of galactic dynamics, they identified a critical detail: the object's trajectory aligns with specific regions of the galaxy. The velocity relative to the local standard of rest, combined with the direction from which the object approached, suggests that the comet did not originate from a random direction in space. The trajectory suggests specific locations within the Milky Way where the object might have originated. The most likely origin region, based on galactic dynamical analysis, lies toward the direction of the galactic core, not directly toward the supermassive black hole at the galaxy's center, but toward the dense stellar population of the inner galaxy. The region where stars concentrate most heavily, the region where civilizations, if they exist, would most likely cluster given the abundance of stellar systems. The region from which, statistically, the most advanced civilizations would emerge. 3i Atlas is heading in that direction. Not directly, its trajectory curves through space under the influence of the sun's gravity and the galaxy's gravitational field. But the general vector of escape, the direction of departure after leaving the solar system, points toward the galactic center, points toward home, points toward the civilization that created the probe billions of years ago. The journey will take an incomprehensibly long time. Even if 3I Atlas maintains its current velocity of approximately 58 kilometers per second relative to the Sun, approximately 0.019% the speed of light, the object will require thousands or tens of thousands of years to traverse the interstellar medium and reach the region of space from which it came. But this is not a problem for a civilization that operates on cosmic timescales. A civilization that thinks in millions of years. A civilization where individual probes are assets deployed across centuries and millennia, with return times measured in astronomical epochs. Now consider the transmission of the report. The data gathered by 3I Atlas is enormous: spectroscopic readings of thousands of asteroids, atmospheric composition measurements for multiple planets, detailed analysis of Earth's technological infrastructure, radio signal intercepts and analysis, magnetic field measurements, thermal radiation profiles, orbital parameters of every significant body in the solar system. All of this information, encoded in digital format, represents petabytes of data, perhaps exabytes. The computational requirements to analyze and compress this information, to extract the critical intelligence about threat levels and technological development, would be enormous, even for an advanced civilization. There are two primary scenarios for how this data might be transmitted back to the origin civilization. Each has profound implications for how and when information reaches its destination. The first scenario is the light speed report. In this scenario, 3I Atlas possesses onboard transmitters capable of producing extremely powerful, highly focused beams of electromagnetic radiation. These transmitters would aim the signal in the direction of the origin civilization. The signal, traveling at the speed of light, the universal speed limit, would propagate across the vast distances of interstellar space toward its destination. This is the fastest possible transmission method within physics as currently understood. But consider the timescales involved. If 3I Atlas originated from a star system 10,000 light-years away, a signal traveling at light speed would require 10,000 years to reach that destination. 10,000 years. The signal sent from 3I Atlas in November 2025 would not arrive at its destination until the year 12025. By that time, human civilization would have undergone unimaginable transformation or would have ceased to exist entirely. The return civilization's response, if one were sent, would take another 10,000 years to reach Earth. The round-trip communication time would be 20,000 years. For even closer origin points, star systems 1,000 light-years away, the communication delay would still be 1,000 years. Even the nearest possible source, if it existed at a distance comparable to the closest known stars, would involve communication delays measured in years or decades. The light speed report scenario is thus not a mechanism for real-time communication. It is a mechanism for transmitting archived data across vast timescales. It is a method for ensuring that even if the probe itself never returns, the data it gathered survives and reaches home. The critical question becomes, would an advanced civilization actually receive this transmission? The signal, if sent by 3I Atlas, would be extremely faint by the time it reached its destination after traveling thousands of light-years. Interstellar space contains dust, cosmic rays, plasma, and other materials that scatter and attenuate electromagnetic radiation. A signal sent through this medium would degrade. The power level would drop by orders of magnitude through inverse square spreading alone. The signal-to-noise ratio would become vanishingly small. Detecting such a signal would require receivers of astounding sophistication, receivers that could detect individual photons with near-perfect efficiency, that could recover signal from overwhelming noise, that could distinguish an artificial transmission from the natural radio background of the galaxy. But a civilization billions of years advanced, a civilization that has mastered technology to the point of controlling stellar systems, of constructing megastructures, of manipulating the very fabric of space-time itself. Such a civilization would absolutely possess the technological capability to detect these signals. Advanced receivers positioned strategically throughout the galaxy. Computational systems capable of analyzing cosmic noise and extracting hidden signals. Directed detection systems optimized for the specific modulation patterns and frequencies that the civilization itself uses. The light speed report would be received. It would arrive thousands of years after 3I Atlas departed Earth. But it would arrive. And the information about Earth would be available to the civilization that sent the probe to conduct the initial reconnaissance. The second scenario is far more profound in its implications: the physical return. In this scenario, 3I Atlas itself is the message. The probe is designed not merely to transmit data through space, but to carry the data physically back to its origin. The accumulated information is stored in some form of durable storage medium, perhaps biological storage, perhaps quantum storage, perhaps technology beyond human conception, and remains aboard the probe as it travels through the void. The advantage of physical return is that the information arrives intact and uncorrupted. There is no signal degradation across thousands of light years. There is no danger of the signal being lost in cosmic noise. The data simply exists aboard the probe, waiting for the probe to arrive at its destination. The probe becomes a time capsule, a repository of knowledge, a physical archive of the reconnaissance mission that can be analyzed, studied, and utilized by the civilization that created it. But there is a problem. The journey is extraordinarily long. If 3I Atlas maintains its current velocity of 58 km per second, it would require approximately 130 million years to traverse 250,000 light-years, a distance comparable to the distance from the Milky Way to the Andromeda Galaxy. Even at velocities approaching the speed of light, the interstellar journey would require timescales of tens of thousands of years or longer. A civilization planning for such timescales would need to operate with patience that transcends human comprehension. The probe is launched. Centuries or millennia pass. The probe travels through the void, its onboard systems maintaining power and computational functionality across geological timescales. Other probes are launched toward other stellar systems. A network of reconnaissance assets gradually spreads throughout the galaxy, each one carrying its own data, each one returning home in its own time, each one building a comprehensive picture of the cosmos and the civilizations it contains. But here is where the concept of the long echo becomes crucial. This echo is not acoustic, it is temporal. It is the lag between the moment of reconnaissance, October 2025, when 3I Atlas reached perihelion, and the moment when the information about that reconnaissance reaches the advanced civilization that sent the probe. The echo can be described as the communication delay measured in centuries or millennia. The echo is the period during which Earth's civilization exists in ignorance, unaware that it has been evaluated, unaware that a report about its nature and potential threat level is traversing the cosmic void toward powers billions of years advanced. And during this echo, this period lasting thousands or millions of years, Earth's civilization continues to develop, continues to build weapons, continues to expand into space, continues to accelerate technologically. The advanced civilization that received the report cannot respond immediately, cannot launch countermeasures immediately, cannot take action immediately. By the time any response could physically reach Earth, after thousands of years of travel time, Earth's civilization might have transformed completely. Might have achieved Type 1 civilization status, might have become genuinely dangerous to an advanced civilization that launched preemptive reconnaissance a million years earlier. This is the peculiar horror of the long echo scenario. Earth's civilization exists in a temporal bubble. The civilization that sent 3I Atlas is billions of years advanced, billions of light years distant, operating on timescales of millions of years. The reconnaissance probe brought back data about Earth in 2025, but the response if one comes, will not arrive until the year 1425, or 1425, or 101425. By then, humanity might be extinct, might be Type 1, might be expansion-ready and prepared for conflict with whatever civilization threatens them. The long echo thus creates temporal asymmetry. The advanced civilization has information about Earth as Earth exists in 2025, but Earth, over the intervening centuries or millennia, will have changed completely. Earth's threat level in the year 4000 or 1000 cannot be accurately predicted based on data gathered in 2025. The advanced civilization must therefore make decisions based on incomplete information, must project technological development trajectories, must estimate whether Earth will remain a manageable threat or will eventually become dangerous. And this projection is where the decision point becomes critical. The advanced civilization must ask, will Earth's technological development continue its current exponential trajectory? If yes, then Earth will reach Type 1 status within the next few thousand years. At that point, Earth becomes dangerous. At that point, preemptive action becomes justified. The civilization must launch the countermeasure now, understanding that the strike will not arrive for thousands of years, but that by the time it arrives, it will be neutralizing an existential threat. Or, conversely, will Earth's technological development plateau or reverse? Will internal conflict destroy human civilization? Will environmental collapse prevent further advancement? Will humans deliberately choose to restrict technology development? If any of these occur, then Earth remains safe. Earth remains beneath the threshold of threat. Earth is allowed to continue existing, watched, monitored, constantly re-evaluated, but not targeted for elimination. This is the calculation that happens across the long echo. This is the fundamental question: is Earth currently non-threatening enough to be spared, accepting the risk that Earth might become dangerous in the future? Or is Earth sufficiently likely to become dangerous that preemptive action is justified now? But here is the crucial insight. Humanity cannot know which decision was made, cannot know whether a preemptive strike has been dispatched, cannot know whether at this very moment relativistic projectiles are being accelerated toward Earth at speeds approaching light speed, projectiles that will arrive centuries or millennia from now, carrying momentum sufficient to sterilize the planet. Or cannot know whether the advanced civilization has decided to spare humanity, to allow the species to continue developing, to wait and see what path human civilization chooses, to monitor and evaluate without immediate intervention, accepting the risk that humanity might eventually pose a threat. The long echo means that Earth's civilization operates without information about its fate, operates without knowledge of whether survival has been granted or extermination scheduled, operates under the assumption that the decisions made in the distant future, decisions made by an intelligence billions of years advanced, operating on timescales of millions of years, will determine whether humanity has a future beyond a certain point. Consider the trajectory into which Earth now finds itself inserted. On October 28, 2025, 3I Atlas reached perihelion and conducted its course correction. Within days, the data about the probe's artificial nature will circulate through human scientific institutions. Within weeks, the implications will become clear to governments, militaries, and strategic planners. Within months or years, the international community will respond. Some nations will accelerate weapon development. Some will propose technologies for detecting and destroying incoming threats. Some will attempt to accelerate humanity's technological development trajectory. Some will argue for peaceful restraint. The debate will be fierce. The strategic calculus will be agonizing. But all of these responses will constitute new data, new information about how humanity is reacting to the knowledge of external surveillance. And this new data will feed into the threat assessment of the advanced civilization when it eventually hears about humanity's response to the discovery of 3I Atlas. The long echo thus contains within it a recursive loop. the reconnaissance mission brings back data about Earth. The data causes Earth to respond. The response generates new data about Earth's strategic thinking and capabilities. That new data, transmitted or carried back by subsequent probes or surveillance systems, informs updated threat assessments. Those assessments might change the decision about whether humanity should be eliminated or allowed to continue. And the tragedy of this situation is that humanity cannot influence the decision being made across the long echo, cannot negotiate, cannot communicate, cannot propose peaceful coexistence. The advanced civilization will not respond to human messages, will not engage in diplomatic channels, will not listen to human appeals or human offers of cooperation. The decision will be made based on mathematical analysis of threat probability, on game-theoretic calculations of cosmic survival, on the evaluation of technological development trajectories that have nothing to do with human intentions or human moral values. The comet departs, the report travels, the long echo propagates, and Earth enters a new era in its cosmic history, an era in which the future of the species has been placed in the calculation of another intelligence, measured against thresholds we cannot see, evaluated according to principles we do not fully understand, with consequences we cannot influence or escape. Somewhere in the direction of the galactic core, traveling at the speed of light or carried aboard a probe moving through the void, the data about Earth's existence and threat level is traversing space. Someday, perhaps thousands of years from now, perhaps millions of years from now, that information will reach its destination. An intelligence billions of years advanced will read the report, will integrate it with information from other probes surveying other stellar systems, will make a decision. And humanity will continue, unaware that the evaluation is underway, unaware that the decision has been made or will be made, operating under the assumption that tomorrow will come, that civilization will continue developing, that the future is open and uncertain. But operating in a future that has already been calculated by an intelligence we have never contacted, have never negotiated with, have never even confirmed exists. This is the long echo, the final revelation of what 3i Atlas represents, not the immediate threat, not the destruction coming tomorrow, but the knowledge that somewhere a decision about humanity's right to exist is being made, and the knowledge that when the response arrives, if a response comes, it will arrive as an echo of a calculation made thousands of years in Earth's past. An echo of evaluation, an echo of judgment, an echo that will fundamentally transform everything we know about human civilization's place in the cosmos.